We're often told that our lives are precious and unique, a one-time only performance, a single, fleeting flash of consciousness in an eternity of silence. Every choice, every moment a singular event that will happen once and never again. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. But what if that's not the whole story? What if some of the most mind-bending ideas in physics, if they turn out to be true, have a different plan for you? What if the universe is truly infinite? Some cosmological models, when taken to their logical conclusion, suggest that in an infinite cosmos, your exact life down to this very moment, the thoughts in your head, the air in your lungs is not just a possibility, but a near inevitability, an event that could happen again, and again, and again. This raises a new question: are you living a life worth repeating? The heaviest weight? A demon's proposition? Let's start not with physics, but with a thought experiment so profound, so terrifying, that the philosopher who conceived it called it the heaviest weight. Picture your loneliest loneliness. A quiet night, the world's asleep, and you are alone with your thoughts. Suddenly, a demon appears. It doesn't have a pitchfork or breathe fire. It just speaks. It says to you, this life as you now live it and have lived it, you will have to live once more and innumerable times more, and there will be nothing new in it, but every pain and every joy and every thought and sigh and everything unutterably small or great in your life will have to return to you, all in the same succession and sequence, even this spider and this moonlight between the trees, and even this moment and I myself. The eternal hourglass of existence is turned upside down again and again, and you with it, speck of dust. This is the famous proposition of eternal recurrence, from the 19th century philosopher Friedrich Nietzsche. How would you react? Would you throw yourself down and curse the demon? To be trapped in an endless loop of your worst mistakes, your deepest regrets, your most excruciating heartbreaks. To relive every failure, every loss, not once, but infinitely. The sheer horror is almost unimaginable. It's a vision of hell, not in fire and brimstone, but in the perfect, unending repetition of your own flawed existence. Or have you ever had a moment so perfect, so filled with joy, that you wished it could last forever? A moment so beautiful you'd be willing to endure all the suffering of your life, just to experience it one more time? If you could tell the demon, you are a god and never have I heard anything more divine, you've understood the other side of this heaviest weight. You've started to grasp the incredible power hidden inside this terrifying idea. Nietzsche probably wasn't making a literal claim about the cosmos. He was posing a hypothetical question to test the ultimate value of a life. It's an ethical gut check. Could you look at your life, in its entirety, with all its messiness and pain, and still say, yes, again? This is the philosophical heart of our journey. But here's where things get wild. In the century and a half since Nietzsche posed his question, modern physics has independently arrived at concepts that make his idea feel eerily plausible, not as a repetition in asterisk time, but in asterisk space. To understand how, we need to zoom out, way out. The cosmic bubble, our observable universe. Let's step back from the demon and look up at the night sky. We see stars, galaxies, the faint river of the Milky Way. But what are we really looking at? Picture yourself inside a giant, invisible sphere. This is our observable universe. It contains everything whose light has had enough time to reach us since the Big Bang, about 13.8 billion years ago. Now, you'd think this sphere would be 13.8 billion light-years in radius. But as light travels, the very fabric of space is stretching. This cosmic expansion means the actual edge of what we can see is much farther away, about 46.5 billion light-years. That makes the diameter of our cosmic bubble a staggering 93 billion light-years. Inside this bubble? A cosmic zoo. Scientists estimate there are hundreds of billions of galaxies, with some earlier models suggesting as many as 2 trillion. These galaxies clump together in clusters, which form even larger superclusters, all woven into a vast, web-like structure. We live in the Laniakea supercluster, a colossal structure containing roughly 100,000 other galaxies and stretching over 500 million light-years. When we look at this cosmic web on the largest scales, a remarkable pattern emerges. The universe appears to be both homogeneous, roughly the same everywhere, and isotropic, looking the same in all directions. This is a foundational assumption of modern cosmology, known as the cosmological principle, and it's strongly supported by what we see. There's no special center, no cosmic "you are here" sign. The best evidence for this uniformity is the cosmic microwave background, or CMB. The CMB is the oldest light in the universe, a faint afterglow from just 380,000 years after the Big Bang. Back then, the universe was a hot, dense plasma soup. As it expanded and cooled, atoms formed, and light was set free for the first time. Today, that ancient light washes over us as a faint microwave glow, with a nearly perfect, uniform temperature of just 725 Kelvin. Those tiny temperature fluctuations, variations of just 1 part in 100,000, were the seeds that gravity nurtured into the galaxies and superclusters we see today. But here's the reality bending point. This 93 billion light-year bubble is just our observable universe. It's a horizon of information, not a physical wall. There's no reason to believe the universe just stops where our view does. So, the biggest question in cosmology is, what lies beyond the bubble? Beyond the horizon? The leap to infinity? One of the most fundamental questions scientists are trying to answer is about the overall shape of the universe. According to Einstein's theory of general relativity, there are 3 basic possibilities. It could be positively curved like a sphere, negatively curved like a saddle, or perfectly flat. The simplest way to measure this shape is to go back to the cosmic microwave background. By studying the size of those tiny temperature fluctuations, cosmologists can figure out the geometry of the space that ancient light has been traveling through. And the results, most recently from the Planck satellite, are clear. On the largest scales, the universe is astonishingly, almost perfectly, flat. Now, this could mean the universe is just so gigantic that our observable bubble is like a tiny patch on a sphere the size of Jupiter. It would seem flat to us. For a curved universe to look this flat, some estimates suggest it would need to be at least several hundred times larger than what we can see. However, the simplest and most straightforward interpretation of this flatness is that the universe is, in fact, spatially infinite. It just keeps going. This isn't just a guess, it's a key feature of our leading theory for the universe's first moments, cosmic inflation. Developed in the 1980s by physicists like Alan Guth and Andre Linde, inflation proposes that in the first tiny fraction of a second after the Big Bang, the universe underwent a period of hyper-accelerated, exponential expansion. This incredible stretching would have ironed out any initial curvature, blowing the universe up to such an epic scale that its geometry would naturally appear flat, matching our observations perfectly. Furthermore, many popular models of inflation, like eternal chaotic inflation, suggest this process might never truly stop. While inflation ended in our local region, it could be continuing in other, more distant regions, constantly spawning new patches of space. So, while we can't prove it, anything beyond our horizon is by definition unobservable. Our best observations point to a flat universe, and our leading theories provide a mechanism that would make it infinite. And it's here that Nietzsche's demon starts to feel less like a ghost story and more like a physics lesson. The cosmic echo. Why infinity could mean repetition. We've now arrived at the core of the argument, where mind-bending physics leads to a philosophical bombshell. The logic is simple, but its implications are enormous. It works like this. 1. Our evidence is consistent with an infinite universe. 2. Within any finite patch of that universe, like our own, there are only a finite number of possible ways to arrange matter and energy. Let's unpack that second point. Everything we see is made of a finite number of particles arranged in specific quantum states. According to a widely discussed idea in physics, the number of possible configurations those particles can take within a given volume is also finite. It's an unimaginably large number, but it's not infinite. Physicist Max Tegmark uses a simple analogy, a deck of cards. There's a huge but finite number of ways to shuffle a 52-card deck. If you shuffle it an infinite number of times, you are mathematically guaranteed to repeat the exact same order infinitely many times. Now, let's scale that up. Think of a cosmic patch, the size of our observable universe. If the cosmos is truly infinite, it contains an infinite number of these cosmic patches stretching out beyond our view. With an infinite number of patches to play with, and only a finite number of ways to arrange the cards inside each one, the laws of probability suggest that every single possible arrangement should occur somewhere, and not just once, but an infinite number of times. This isn't necessarily a theory of other dimensions. Many physicists refer to this as a level 1 multiverse, different regions within our own familiar, three-dimensional space, just so incredibly distant that we can never see or interact with them. It's the logical consequence of having finite stuff in an infinite space. This means that somewhere out there, in that infinite expanse, another cosmic patch could exist that is identical to ours. A patch with a Milky Way, a solar system, an Earth, and a particle-for-particle copy of you, living your exact life. Based on this logic, physicists like Tegmark have even made back-of-the-envelope calculations for how far you'd have to travel to meet your first doppelganger. The number is a 1 followed by so many zeros it would be impossible to write down. The distance is functionally infinite, but the speculative logic is compelling. The Hall of Mirrors, infinite copies, infinite lives. Let's just pause and absorb what this idea implies. If this model of an infinite universe is correct, there wouldn't just be one copy of you out there. There would be an infinite number of them. An infinite number of yous are, right now, experiencing this same moment. But it wouldn't stop there. Every possible variation of your life could also exist. Somewhere out there might be a version of you who made a different choice at a critical moment. A you who took that job, who stayed in that relationship, who didn't make that mistake that haunts you. There could be a you who became an astronaut, a celebrated artist, a brilliant scientist, and yes, a you who made worse choices, whose life is a tragedy. Every possible outcome of every choice you've ever faced might be playing out, somewhere in the infinite tapestry of the cosmos. Your life wouldn't be a single story, but an infinite library of stories. This concept can feel like it shatters our ideas of uniqueness. Does free will have the same meaning if every possible choice is actually made by one of your cosmic duplicates? These are deep, unsettling questions that physics hands over to philosophy. The science gives us the what if, the potential for infinite repetition in space, but it can't tell us how to live with it. And that brings us right back to the demon. In a strange way, this cosmological idea echoes the demon's proposition. It doesn't suggest your life will repeat in asterisk time, but that identical lives could be playing out across the infinite canvas of space. Faced with this staggering possibility, how are we supposed to live? Do we collapse in despair at our cosmic insignificance? Or do we find a way to embrace it? Amor fati. The formula for greatness. This is where we have to turn back to Nietzsche. Because he didn't just pose the question, he offered a powerful, life-affirming answer. He called it amor fati, Latin for love of one's fate. Amor fati is the joyful and active acceptance of everything that has ever happened, is happening, and will happen in your life. It isn't just passive resignation. It's not shrugging and saying, it is what it is. It is looking at your life, with all its beauty and its horror, its triumphs and its tragedies, and saying a resounding, wholehearted yes. Nietzsche wrote, "My formula for greatness in a human being is amor fati asterisk, that one wants nothing to be different, not forward, not backward, not in all eternity, not merely bear what is necessary, still less conceal it, but love it." How does this connect to eternal recurrence? The thought experiment becomes the ultimate tool for achieving amor fati. It challenges you to live in such a way that you would want to relive every single moment. It becomes the ultimate motivation to create a life so meaningful and authentic that the prospect of its eternal repetition would be a celebration, not a punishment. If you lived as if every decision would be repeated for all eternity, how would that change what you do today? The weight of that thought is immense. Suddenly, every small act of kindness or cruelty isn't a fleeting event, but an eternal one. The choice to chase a passion or give in to fear isn't a choice for one lifetime, but for all of them. This perspective imbues every moment with an almost unbearable significance. It compels you to become who you are, as Nietzsche urged, to strip away the inauthentic parts of your life and focus only on what truly matters to you. Live in a way that if the demon's proposition were true, you would welcome it. Create a life that is a work of art you would be proud to display for eternity. Love your fate so completely that its infinite repetition is the greatest possible reward. This is the profound pivot from the physics of repetition to the philosophy of affirmation. The universe may be indifferent, but we don't have to be. We have the power, right here and now, in this instance of our lives, to live with such purpose that we can look our fate in the eye and love it. We started with a simple, unsettling question: will your life repeat forever? We journeyed from a philosopher's thought experiment to the speculative frontiers of modern cosmology. We saw how our observable universe is likely just one bubble in a possibly infinite cosmos. We learned how this idea of infinity, combined with some core assumptions, leads to the startling possibility that everything that can happen, might happen, an infinite number of times, not as a cycle in time, but as an echo across the endless expanse of space. Somewhere out there, an infinite number of your cosmic twins could be living out your life. Some identically, others living the lives you might have had. This can feel terrifying. It can make our individual existence feel small, but it can also be the most powerful motivation imaginable. The idea of eternal recurrence, whether a physical possibility or a philosophical tool, gives us a new lens to see our lives through.
It elevates every moment to a matter of eternal significance. It challenges us not just to live, but to live well, to live authentically, to live in a way we'd be willing to repeat forever. The universe may be infinite, but the life you are consciously experiencing is this one, right here, right now. The power to make it a life worth repeating is entirely in your hands. So, let me ask you one last time. It's no longer the demon's question, but your own. If you had to live this exact life over and over for eternity, what would you change, starting today? Let me know in the comments below. And if this journey into the cosmos and the self sparked something in you, consider subscribing for more explorations into the biggest questions of our existence. What does infinite really mean? If you keep traveling outward in your mind, beyond the Earth, beyond the Sun, beyond the quiet spiral of the Milky Way, there comes a point where language begins to feel too small for what it is trying to describe. We can say vast. We can say immeasurable. We can say almost unimaginably large. But none of those phrases quite reach the strange idea waiting for us here. Because there is a difference between something that is simply enormous and something that may have no end at all. Tonight, that is the difference we are going to sit with. Not just a large universe, but a universe that could be infinite. That word, infinite, is familiar enough that it almost feels harmless. We use it casually. Infinite possibilities. Infinite patience. Infinite space. But in science, infinity is not just another way of saying very, very big. It is something stranger than that. Something that does not run out. A hotel can be full. A road can reach its final mile. But an infinite thing never arrives at that final point. No matter how far you go, there is always more. The easiest mistake to make is to imagine infinity as a giant container. An impossibly huge box with more stars than we could ever count. But even that picture is still too small, because a box still has walls. It still has an inside and an outside. Infinity does not. If space is truly infinite, then it does not end in darkness, or in some final cosmic fence. It simply continues. Quietly, endlessly, in all directions. This is where the question itself starts to change. When people ask what lies beyond the edge of the universe, they are already assuming that an edge must exist. But not everything meaningful has an edge. The observable universe, the part we can see, is not the same thing as the entire universe. It is only the region from which light has had time to reach us. In other words, it is a horizon, not necessarily a wall. Imagine standing in a foggy field at night with a lantern. You can only see so far, not because the field ends there, but because your light does. The observable universe is a little like that. We are surrounded by a cosmic limit to what has become visible to us, because the universe has a finite age and light travels at a finite speed. Beyond that horizon, space may continue for an astonishing distance. It may curve back on itself in ways we do not easily picture. Or it may go on forever. Our horizon is not automatically the universe's boundary. It may simply be the edge of our current view. Once the universe is allowed to be larger than what we can observe, the old human instinct for neat endings starts to loosen. We are used to rooms with walls, books with final pages, roads that arrive somewhere. Infinity breaks that habit. It suggests that reality may not be built around closure at all. It may be built around continuation. Now there is another distinction worth making. When people hear the phrase infinite universe, they usually think of infinite space. But time can matter too. A universe may be finite in age and still infinite in extent. Or it may be limited in size and continue for an immense duration. These are different kinds of largeness, and they lead to different consequences. Infinite space means there is no last region of cosmos, no final galaxy, no terminal edge where reality stops. Infinite time means there is no last moment after which nothing further can happen. And here, very gently, the deeper implication begins to appear. Because in a reality with enough room, or enough time, even rare things begin to behave differently. In a small world, rarity can protect uniqueness. In a vast enough world, rarity starts to lose that protection. Events that seem impossibly unlikely do not become impossible just because they are uncommon. If the stage is large enough, or the play runs long enough, unlikely arrangements may still appear. But infinity does not mean magic. It does not mean anything can happen in any way at all. An infinite universe still obeys laws. Gravity still shapes matter. Stars still form out of gas. Atoms still combine in limited ways. Infinity is not chaos without structure. It is structure without an obvious end. And that matters, because repetition does not come from randomness alone. It comes from rules acting again and again across enough space, or enough time, for patterns to return. You can think of it like waves on a dark ocean. Each wave is shaped by the same underlying laws of water, wind, and motion. No two waves are identical in every small detail, and yet their family resemblance is unmistakable. Now imagine not thousands of waves, but endlessly many. After a while, shapes begin to echo. Not because the ocean is trying to repeat itself, but because the same laws are working over and over again. This is the point where infinity stops feeling abstract and starts to feel personal. Because if the universe is only large, then your life may seem unique in the simplest possible sense, one rare event in a finite sea of events. But if reality is truly infinite, then uniqueness becomes harder to define. A pattern made once may be made again. A world arranged one way may be arranged elsewhere in almost the same way. And somewhere inside that possibility sits the question that pulls so many people toward this subject. If matter can form the same broad structures again and again, then could a life, a mind, or even a moment return? We are not answering that fully yet. We are only preparing the ground beneath it. Because before we can ask whether a life could repeat, we first have to understand what infinity really does to probability, to patterns, and to the architecture of existence itself. A universe with no end does not merely give us more stars. It gives reality more chances. And perhaps that is the quietest, strangest part of all. To say that the universe may be infinite is to say that the old comfort of only once may not be guaranteed by physics. In a reality without a final wall, repetition is no longer just a poetic thought. It becomes a possibility we may have to take seriously. There is a simple way to feel the strangeness of this without needing equations. Picture a deck of cards being shuffled in a quiet room. Every shuffle creates a different order. Some arrangements feel ordinary. Others would seem almost impossible to guess in advance. And yet every arrangement is made from the same 52 cards, following the same rules. The number of possible orders is staggeringly large, so large that a particular arrangement feels unique. But the important point is that the possibilities, however vast, are still not unlimited in the truest sense. They are finite. Immense, yes, but finite. That distinction matters more than it first appears to. Because when physicists think about repetition in the universe, they are often dealing with something similar. Not cards, of course, but matter, energy, particles, temperature, and the physical states that a region of space can take on. If the number of possible arrangements in a given region is finite, while the amount of space is infinite, then something curious begins to happen. The arrangements do not have to stay unique forever. Given enough cosmic room, they can repeat. This sounds mysterious at first, but the logic itself is surprisingly gentle. If you have only a limited number of ways to arrange something, and you keep creating new instances forever, then sooner or later you begin to repeat earlier patterns. It is the same quiet principle behind running out of combinations. Imagine a mosaic made from only a certain number of tiles, colors, and positions. A few mosaics may seem original. Many more will look similar. And if the mosaic stretches across an endless plane, then eventually, somewhere far beyond sight, one of the earlier patterns must appear again. Now, the universe is not literally a tiled mosaic, and it is not made of isolated boxes arranged by hand. But this way of thinking helps us approach an idea that otherwise feels too large to hold. In modern physics, a region of space does not have an infinite amount of freedom in every practical sense. There are limits set by energy, by quantum behavior, and by the fact that matter can only organize itself in so many ways under particular conditions. The number of possible states may be unimaginably large, but not necessarily limitless. And if that is true, then in an infinite cosmos, the repetition of patterns becomes less like fantasy and more like arithmetic stretched across eternity. This does not mean that nearby repetitions should exist just around the corner of the galaxy. The distances involved, if such repetitions occur, would likely be beyond anything we can emotionally picture. Not millions of miles. Not even billions of light years in the ordinary sense of travel stories. More like separations so immense that language collapses into layers of zeros and silence. The nearest identical arrangement of atoms, if such a thing exists at all, would probably be unimaginably far away, beyond any practical reach, beyond any message, beyond any future journey. Infinity does not make repetition intimate. It only makes it possible. And even possibility, here, must be handled carefully. Science is most honest when it admits uncertainty. We do not know for sure that space is infinite. The observable universe gives us only a finite sample, and from within that sample we try to infer the larger whole. Measurements suggest that the universe is very close to spatially flat on the largest scales. A flat universe can be infinite, though it does not have to be. It could also be finite in a way that is too large for curvature to be easy to detect. So the idea of an infinite cosmos remains a serious possibility, not a settled fact. But it is a possibility powerful enough that cosmologists think deeply about its consequences. One of those consequences is that infinity changes how we think about uniqueness. On an ordinary human scale, uniqueness feels obvious. There is one earth beneath your feet, one sequence of days that became your life, one set of memories that belongs to you. And from inside that experience, uniqueness feels not just probable, but absolute. But physics is not required to preserve the feeling of uniqueness simply because it matters to us emotionally. Physics only follows what the laws allow. And what the laws may allow, in an infinite setting, is repetition without intention. No hidden force needs to decide that something should return. No cosmic author needs to rewrite the same chapter. Repetition can emerge naturally from abundance. If the universe contains endlessly many regions, and each region is governed by the same physical laws, then structures familiar to us may arise again and again, not because they are special in a mystical sense, but because there are only so many ways matter can be matter under those conditions. There is something strangely calming in that. We are used to thinking of repetition as boredom, as routine, as the dim cycle of ordinary life. But cosmic repetition is different. It is not a tired loop. It is not the universe being lazy. It is what happens when law and scale meet each other in silence. The same ingredients, the same rules, more room than we can truly grasp. And from that, echoes. You can see smaller versions of this idea all around nature. Snowflakes, for all their beauty, are shaped by the same water molecules and the same crystal geometry. Trees branch according to repeated biological patterns. Spiral galaxies, separated by unimaginable gulfs, still resemble one another because gravity and rotation guide matter into recurring forms. Nature does not fear similarity. It creates it often. What changes in the cosmic version is simply the scale. And once scale becomes infinite, recurrence takes on a different emotional weight. Because then the question is no longer just whether galaxies repeat, or whether atoms can gather into familiar shapes. The question becomes whether complexity itself can recur. Whether a planet like Earth could appear again. Whether history-like sequences could unfold again. Whether a person, with a particular face, voice, and inner life, could re-emerge somewhere in the endless architecture of space. For now, it is enough just to notice how we arrived at such a strange doorway. Not through myth, not through wishful thinking, not through a desire to be comforted, but through a quiet chain of reasoning. If space is infinite, and if physical laws are uniform, and if the number of states in a given region is finite, then repetition is not an emotional idea. It is a structural one. That does not tell us how often repetition happens. It does not tell us whether exact copies truly exist. And it does not yet tell us what kind of repetition we mean. A loose resemblance is one thing. An exact atomic duplicate is another. A repeated consciousness is stranger still. These are different levels of sameness, and they must be separated carefully if we want to think clearly. But the foundation has now been laid. Infinity is not just endless distance. It is endless opportunity for patterns to appear, disappear, and perhaps return. And maybe that is why infinity feels so unsettling when we stop to really consider it. Not because it is empty, but because it is fertile. Not because it erases meaning, but because it multiplies possibility. An infinite universe is not merely more of the same darkness. It is a stage vast enough that even the rarest arrangements may not remain singular forever. So as we move forward, the next step is to look more closely at the patterns themselves, at how matter builds structure, at why the number of possible arrangements, though immense, may still be limited in any one cosmic region, and at how that quiet limit, combined with limitless space, opens the door to one of the most haunting thoughts in cosmology. That somewhere, impossibly far away, the universe may have already arranged itself into something astonishingly familiar. To understand why this possibility is taken seriously, it helps to slow down and look at a very simple principle. Not a dramatic one, not a mysterious one, just a quiet principle that appears again and again in mathematics and physics. If you have more opportunities than you have distinct outcomes, repetition becomes unavoidable. It sounds almost too plain to matter. But some of the strangest ideas in cosmology rest on foundations like this. A child can see the shape of it. If you place more pigeons into fewer pigeonholes, at least one hole must hold more than one pigeon. It is not magic. It is not philosophy. It is simply what happens when possibilities are outnumbered by attempts. And in a strange way, infinity turns the universe into a place where that quiet logic begins to whisper across impossible distances. Now, of course, the universe is not a row of pigeonholes, and your life is not a number pulled from a small bag. Reality is richer than that. But the underlying idea still matters. If a particular region of space can only exist in some finite number of distinguishable states, however enormous that number may be, then an infinite universe has room to realize those states again and again. Somewhere, eventually, patterns must recur. This is where people often feel resistance, and it makes sense. Because we instinctively associate the universe with endless complexity. And in one sense, it is endlessly complex. The details of a life, the movement of clouds, the shape of coastlines, the exact arrangement of memories in a human mind, all of this feels too intricate to repeat, too alive, too layered, too precise. But complexity and infinity do not cancel each other out. In fact, complexity can be swallowed by scale. Think of sand on a shoreline. To the eye, the grains seem beyond counting. If you took a handful and let it slip through your fingers, it would feel absurd to imagine any two handfuls ever matching perfectly. And yet if the number of possible grain arrangements were limited, while the beach extended forever, then no matter how subtle the differences seemed, some arrangements would eventually return. Not nearby, not often, but somewhere. In cosmology, that somewhere is what changes everything. When physicists talk about the possible states of a region, they are not usually talking in the casual language of appearances. They are thinking more fundamentally. How can particles be arranged? How much energy is present? What quantum states are allowed? What structures can form under those conditions? A human brain, a planet, a star, a galaxy, all of these are made from matter following laws. The number of ways matter can be configured may be almost unimaginably large, but if it is not truly infinite within a bounded region, then infinity outside that region becomes profoundly important. This is why an infinite universe does not merely give us more space. It changes the meaning of rarity itself. In ordinary life, rare means special because it may happen once, or almost never. But in an infinite setting, rare no longer guarantees singularity. A rare thing may still happen infinitely many times if the stage is endless enough. That is a difficult thought for the human mind, because our intuition was built for villages, seasons, roads, faces, and finite lifetimes. It was not built for endless physical reality. And yet the universe does not have to feel intuitive in order to be real. There is also a softer, more emotional side to this idea, and that may be one reason it lingers so strongly in people's minds. If patterns repeat in an infinite cosmos, then the universe becomes less like a one-time performance and more like a vast field of recurring forms. Galaxies are not singular miracles. Stars are not singular miracles. Planets may not be singular miracles either. And once you accept that nature comfortably repeats stars, spirals, atoms, and worlds, it becomes harder to say with complete confidence that everything meaningful about your existence must occur only once. That does not mean you, here and now, are diminished. Quite the opposite. If anything, it places your life inside a larger and more haunting order. Your thoughts, your fears, your small remembered moments, the sound of a voice in another room, the feeling of lying awake in darkness wondering what any of this means, all of it may belong not only to one isolated point in reality, but to a kind of pattern that matter itself can express under the right conditions. There is something almost tender in that possibility. Not comforting in a simple way. Not frightening in a simple way either. Just strange. Strange in the deep cosmic sense. The kind of strange that does not shout, but stays with you after the room has gone quiet. At the same time, we should be careful not to rush too far ahead. Repetition is not sameness in every possible sense. A repeated arrangement of atoms would be one thing. A repeated history would be another. A repeated awareness, a repeated inner life, would raise even stranger questions. If there is another version of you somewhere unimaginably far away, living through a sequence almost identical to yours, is that truly you? Or is it only a copy so perfect that the distinction becomes painful to describe? Physics may be able to speak about arrangements. Consciousness is harder. Identity is harder. Meaning is harder still. But even to reach those questions, we first need this quieter step. We need to understand that infinity changes the statistical landscape of reality. It takes what feels impossible on a local scale and reclassifies it as merely improbable on a cosmic one. And merely improbable things behave very differently when given endless chances to occur. This is part of why the universe can feel both more mysterious and more mechanical at the same time. On one hand, infinity opens the door to astonishing consequences, repeated worlds, repeated lives, repeated observers. On the other hand, those consequences do not require intention or destiny. They arise from law, number, and scale. No guiding hand is needed. No hidden cosmic script has to insist that your story be told again. Repetition, if it exists, may simply be what mattered as when given enough room to keep trying. And perhaps that is one of the deepest shifts in perspective this subject offers. We are used to looking for meaning in the unusual, the singular, the once-in-all history event. But the universe may not organize itself around singularity. It may organize itself around lawful abundance. Around patterns that emerge, dissolve, and emerge again. Around recurrence not as a mystical exception, but as a natural consequence of endless extension. If you let that thought settle for a moment, the night sky changes a little. The stars remain distant. The galaxies remain unreachable. But they no longer feel like isolated decorations scattered across darkness. They begin to feel like members of a larger grammar. Expressions written by the same rules, over and over, across a page with no obvious end. And that page may be far larger than our instincts are willing to admit. So before we move on, it is worth pausing here. We began with a simple question about what infinite really means. And now we can feel the answer becoming heavier. Infinity does not simply mean more. It means that more may continue until the unlikely loses its power to remain unique. It means that a pattern, once formed, may not belong forever to one place alone. It means that the universe, if truly without end, may contain echoes of things we once assumed could never echo at all. In the next part, we move even closer to the heart of that idea. We leave the abstract language of infinity behind, and begin looking at the patterns themselves. How matter builds worlds. How atoms become structure. How structure becomes complexity. And how, from those quiet ingredients, the possibility of repetition begins to feel less like philosophy and more like a consequence of physics. And if these slow journeys through the cosmos help you settle into the night, you can leave a quiet like, subscribe for more, or share your thoughts below. Sometimes the gentlest questions lead to the largest ones. For now, though, just hold on to this. In a universe that may have no end, uniqueness becomes a more delicate thing than it first appears. What seems singular from where we stand may be only locally singular, precious here, repeated elsewhere, beyond any possible horizon. And somewhere in that endless expanse, the same laws may already be arranging familiar pieces into familiar forms, waiting for us, very slowly, to understand what that really means. How matter creates patterns. Take a moment and picture something very small. Not a galaxy. Not a star. Not even a planet. Just a grain of dust resting quietly on a windowsill, or floating unseen through a thin beam of light. It seems insignificant, almost too small to matter in a conversation about the universe. And yet this is where the deeper story begins. Because before there can be planets, oceans, forests, or lives like yours, there must first be matter. Tiny pieces. Silent pieces. Pieces following rules so faithfully that, given enough time and enough space, they can build the same kinds of structures again and again. This is one of the gentlest but most powerful ideas in physics. The universe does not create complexity by inventing new laws for every new object. It uses the same ingredients over and over. The same particles. The same forces. The same quiet instructions written into nature from the beginning. A star is not made with one set of physics while a human hand is made with another. At the deepest level, both are assembled from the same underlying fabric. That is what makes repetition possible. If reality were made from endlessly changing rules, patterns would be harder to talk about. But because the laws are stable, matter has a way of forming recognizable shapes. Everything around you, every object in the room, every memory held in the architecture of your brain, every distant moon and mountain and ringed planet, all of it comes down to a limited cast of characters arranged in different ways. At the atomic level, the universe is surprisingly economical. Hydrogen, carbon, oxygen, nitrogen, iron, silicon. Again and again, these and other elements become the letters with which reality writes its long cosmic story. The vocabulary is not endless. What changes is the arrangement. And arrangement is where the magic, or perhaps the science that feels like magic, begins. Think of language for a moment. The English alphabet has only 26 letters, and yet from those few symbols come poems, laws, lullabies, confessions, histories, prayers, equations, and stories that survive for centuries. The number of letters is small. The number of possible expressions is vast. Matter works in a strangely similar way. The universe does not need an infinite variety of ingredients to produce staggering complexity. It only needs a finite set of building blocks that can combine in many different patterns. This is why chemistry feels almost alive when you look at it closely. A single atom is simple compared to a tree or a whale or a human face. But atoms do not stay alone. They bind. They repel. They attract. They exchange electrons. They settle into structures. Carbon, in particular, is famous for this, because it can connect with other atoms in rich and flexible ways. From that quiet flexibility comes much of the complexity of life. Long chains, rings, branching molecules, proteins folding into intricate forms, DNA carrying patterns across generations. And all of it begins with matter obeying laws. There is something very calming in that thought. The world is not assembled through constant invention. It is assembled through lawful repetition. The same atoms that glowed inside ancient stars now move through oceans, leaves, skin, and breath. The calcium in bones, the iron in blood, the oxygen in lungs, all of it was forged through cosmic processes that happened long before Earth existed. In a very literal sense, The universe builds new things by reusing old ingredients. But matter does not only form complexity through chemistry. It also forms pattern through force. Gravity, in particular, is one of the great sculptors of the cosmos. It gathers. It pulls. It patiently shapes clouds of gas into stars, stars into galaxies, galaxies into clusters. It does not rush. It does not need to. Given enough mass and enough time, gravity will take scattered material and begin drawing it into structure. That is why the universe is not just a random spray of particles. It has architecture. It has rhythm. It has recurring forms. This is why spiral galaxies appear again and again across the sky. Not because one galaxy copies another, but because the same conditions produce similar outcomes. A rotating cloud of matter, influenced by gravity and motion, often settles into recognizable shapes. The result is not perfect sameness. No two galaxies are identical in every detail, but they belong to the same family of possibilities. The same is true of stars. The same is true of planets. And in a quieter way, it is true of the chemistry that eventually makes life possible. Once you begin seeing the universe like this, you notice that nature is full of repeated solutions. Snowflakes form from the same geometry of water molecules. Crystals grow according to repeating atomic lattices. Planets tend to become round because gravity pulls matter toward balance. Rivers branch. Lightning branches. Tree roots branch. Even on Earth, patterns return across scales and across substances, because the laws beneath them remain steady. Nature is not endlessly improvising from nothing. It is exploring what its rules allow. And this is where the idea of repetition becomes more serious. If matter always followed different laws in different regions of space, then every part of the cosmos might become radically alien, and repetition would lose much of its meaning. But as far as we can tell, the universe is remarkably consistent. The same physics that operates here appears to operate in distant stars and galaxies. The spectra of faraway light tell us that the same elements exist elsewhere. The same gravitational behavior shapes remote systems. The same equations still seem to hold. This means the universe is not only vast, it is coherent. It is using the same grammar everywhere we look. That coherence matters more than size alone. Because if the same ingredients and the same rules are at work everywhere, then matter is not free to become absolutely anything. It moves within a landscape of possibilities. Wide possibilities, yes. Astonishingly wide. But still structured. Still bounded by what physics permits. A world of laws is also a world of recurring outcomes. Imagine a musician sitting alone with only a handful of notes. At first that sounds limiting. But then the melodies begin. Some are simple. Some are haunting. Some are grand. The notes remain the same, but the combinations multiply into beauty. Matter behaves like that. The notes are few compared with the scale of what they produce. And once you combine a limited set of ingredients with a universe large enough, patterns do not merely become possible. They become expected. This does not mean every pattern is common. Far from it. A living cell is far rarer than a stone. A conscious mind is rarer still. A life with your exact memories, your exact voice, your exact sequence of quiet and private moments, that would be a pattern of extreme specificity. But rarity is not the same thing as impossibility. That is the threshold we are slowly crossing. Matter has rules. Rules create structures. Structures create repeated kinds of order. And once repeated order exists, the road toward more profound forms of recurrence begins to open. It is also worth noticing that complexity does not appear all at once. The universe builds upward in layers. First particles. Then atoms, then stars, then heavier elements forged in stellar furnaces, then planets, then chemistry rich enough for life, then biology, then nervous systems, then minds able to wonder where they came from. This layered process is one reason the cosmos feels so meaningful. Each stage depends on the one before it. And yet every stage remains physical. Every stage emerges from matter following law. So when we ask whether patterns can repeat in an infinite universe, we are not asking whether miracles can happen for no reason. We are asking whether lawful processes, given enough room, can arrive at familiar destinations more than once. That is a very different question. A quieter one. A more scientific one. It is not about fantasy. It is about whether the same ingredients, under the same rules, may eventually build similar worlds, similar histories, perhaps even similar observers. And that is the deeper reason we have to begin with matter. Before there can be another Earth, there must be atoms. Before there can be another life, there must be chemistry. Before there can be another mind asking whether it has lived before, there must be structure patiently assembled from particles and forces acting over immense spans of time. If these long, quiet walks through the universe help you settle a little more deeply into the night, you can leave a like, subscribe, or share a thought below. It is always a gentle pleasure to know where these ideas find people. For now, just hold on to this first step. The universe builds with repeated ingredients and repeated laws. That alone does not guarantee the return of lives or worlds. But it does create the foundation for recurrence. Matter is not chaos without memory. It is order unfolding through possibility. And somewhere inside that order lies the next question we have to face. If the building blocks are limited, then just how many ways can a region of reality truly be arranged before the patterns begin, however distantly, to come back? That question sounds simple at first. How many ways can a region of reality be arranged? But the more quietly you sit with it, the stranger it becomes. Because a region of space may look empty to the eye, and yet from the point of view of physics, it is never truly empty. There are particles, fields, energy levels, temperature, motion, radiation, and the hidden restlessness of the quantum world. Even a small patch of the universe contains more complexity than the human mind can comfortably hold. And still, when physicists think carefully about such a region, they do not usually imagine an unlimited freedom of arrangement. They imagine possibilities, yes, but possibilities that are constrained. This is one of the most important ideas in the entire journey we are taking. The universe may be vast beyond words, but that does not automatically mean that every local patch of it can take on infinitely many meaningful forms. There may be limits. Not small limits, of course. Not limits we could ever list one by one, but limits all the same. And once limits appear inside a bounded region, repetition begins to move from a poetic feeling toward a physical consequence. Imagine a room filled with books. At first glance, the combinations seem endless. You could place the books in different orders, stack them differently, spread them across shelves, leave some open, close others, rearrange them forever. But the room itself has only so much space. The books are finite. Their positions are finite in any practical sense. Their orientations are constrained by the size of the room and the shape of the shelves. The number of possible arrangements may be enormous, far beyond what any person could ever try, but it is not truly without limit. There is a difference between too many to count and infinite. Physics often lives inside that difference. Now scale that idea down to atoms and particles, and scale the consequences up to cosmology. A bounded region of space, one with a certain amount of energy and a certain volume, may only be able to realize a finite number of distinguishable physical states. That statement hides a great deal of subtle science inside it. It involves thermodynamics, quantum theory, and the deep question of how much information a physical system can contain. But at heart, the idea is surprisingly gentle. A region is not free to be absolutely anything. The laws of nature limit what it can hold and how it can change. This becomes easier to feel if you think about temperature. In ordinary life, temperature seems smooth and continuous. A room can be a little warmer or a little cooler. Water can gently heat on a stove. The air can shift from cold to mild to warm in such small steps that the changes feel almost seamless. But underneath that smooth feeling is motion at the molecular and atomic level. Particles move, collide, exchange energy. The smoothness we experience is really an average over countless tiny events. And in the quantum view of nature, not everything varies in an unlimited continuum. Some aspects of physical systems come in allowed states, allowed ranges, allowed structures. The quantum world has this quiet habit of refusing total freedom. Electrons in atoms do not orbit in any arbitrary way they please. They occupy specific energy levels. Light is emitted in particular frequencies. Matter settles into patterns that are lawful, not limitless. Quantum mechanics is often described as strange, and it is strange, but it is also disciplined. It allows richness, yet within form. It permits variation, yet not without boundary. That matters because if the ingredients of a region are governed by quantized behavior, and if the total energy in that region is bounded, then the number of distinct states that can meaningfully exist there may also be bounded. Enormously large, yes. Beyond any human effort to enumerate, certainly. But not endless in the strictest sense. This is where the universe starts to feel less like an unconstrained chaos of possibilities and more like a library of lawful forms. You can think of it like music once again. A melody may feel infinitely expressive, and in an emotional sense it is. But if you give yourself a finite range of notes, a finite duration, and a finite rhythm, then there are only so many exact melodies you can produce within those bounds. The number may be so large that it might as well be unreachable, but it is still a number. And if an orchestra somewhere in an infinite cosmos kept playing new combinations forever, then eventually, one quiet evening, the same melody would return. This does not yet mean your life returns. That leap is still too large to make in one breath. But it does mean that structure itself lives under limitation. A certain region can only say so many exact things. And if space truly goes on without end, then the lawful sentences written by matter cannot all remain unique forever. There is a related concept in physics called entropy, often described as a measure of disorder, though that phrase can be a little too simple. Entropy is also about the number of microscopic ways a system can be arranged while still looking roughly the same on the outside. A glass of water on a table feels like one ordinary state, but underneath that appearance are countless microscopic configurations of molecules. Physics often cares deeply about this distinction between the surface we perceive and the deeper set of possible arrangements hidden beneath it. When we speak of states, we are often speaking of that deeper level. And once again, the lesson is not that anything goes. It is that many things go, but not all things. A system can wander through a huge landscape of possible states, yet still remain inside a finite terrain if the conditions are bounded. That is why recurrence becomes imaginable. If the terrain were truly infinite in every local sense, repetition would be harder to guarantee. But if the terrain is vast yet finite, then endless wandering across endless space begins to favor return. There is something almost beautiful about the restraint hidden inside nature. We often think of the cosmos as an explosion of freedom, a place where anything might be waiting beyond the next horizon. But science keeps finding structure inside that openness. Constants, symmetries, conserved quantities, allowed states, hidden limits. The universe feels wide because it is wide, but it also feels intelligible because it is shaped. It does not merely spread, it organizes. That is part of why matter can build worlds at all. A completely lawless universe would not give rise to stable atoms, long-lived stars, or complex chemistry. It would not remember form long enough for planets to cool or life to emerge. Stability requires restriction. Complexity depends on law. And law means that the possible ways things can be are not infinite at every step. They unfold within channels. So now we can begin to see the outline of the argument more clearly. The universe uses repeated ingredients. Those ingredients obey repeated laws. Within a bounded region, those laws may allow only a finite number of distinguishable arrangements. If space beyond that region is infinite, then those arrangements may occur again. And if arrangements can occur again, then structures can occur again. Not only stars and stones, but perhaps more elaborate things as well. Of course, there are levels to this. A repeated hydrogen atom is trivial. A repeated crystal is less trivial. A repeated planet is astonishing. A repeated biosphere is more astonishing still. A repeated human life, complete down to every memory and hesitation and private sorrow, that belongs to a realm of rarity so extreme that it almost escapes language. But almost is not the same as completely. That is the quiet force of all this. Physics does not ask whether something feels too extraordinary for our intuition. It asks whether the laws forbid it. And if the laws do not forbid it, infinite reality may someday make room for it. This is also where humility becomes important. We are speaking about possibilities grounded in serious reasoning, but not about certainties we have directly observed. We have not traveled far enough to compare distant regions of the universe in this way. We have not seen an identical Earth. We have not found another life that repeats yours. What we have is a chain of thought built from physical principles, from what the laws seem to allow, and from what infinity would imply if it is real. That is enough to make the idea worth contemplating, but not enough to turn mystery into settled fact. Still, even as a possibility, it changes the emotional texture of the cosmos. The night sky stops being only a display of distant objects. It becomes a field of potential recurrence. A place where matter, given enough room, may eventually circle back into forms it has already expressed. Not because it remembers them, not because it intends them, but because law plus abundance can sometimes imitate memory. And from here, the next step becomes almost unavoidable. If regions of space can only take on so many forms, and if the universe may contain endlessly many regions, then what kinds of patterns are likely to return first? Simple ones, certainly. Chemical ones, perhaps. Planetary ones, maybe. But how far does that ladder of repetition climb? Could it reach worlds like ours? Could it reach histories? Could it reach observers looking up into their own night, asking the same old question in the same hushed human way? That is where we are heading next. Perhaps the most difficult step is not imagining repeated atoms, or repeated molecules, or even repeated planets. The most difficult step is imagining repeated complexity. Because the more detailed a thing becomes, the more unique it seems. A single hydrogen atom does not feel personal. A rock does not feel personal. Even a star, for all its grandeur, still belongs to a familiar cosmic category. But a living world begins to feel different. A world with weather, oceans, seasons, chemistry, and the possibility of life feels less like an object and more like a story. And once we move from stories to minds, the sense of uniqueness deepens even further. That is why this next part must be approached slowly. Nature builds upward through layers, but it does not jump carelessly from one layer to the next. A universe full of particles does not automatically become a universe full of life. First there must be stable atoms, then stars, then heavier elements forged inside those stars, then planets formed from debris and dust, then the long quiet interval in which chemistry can become richer and more elaborate. Then, if the conditions are right, matter may begin doing something extraordinary. It may begin organizing itself not just into structure, but into self-sustaining structure, into life. Even this step alone still feels miraculous to us, and perhaps it should. But miracles in the emotional sense are not always miracles in the physical sense. Life may be rare, but rarity is not the same as impossibility. And in a universe with enough worlds, even rare pathways can be walked more than once. We already know that the ingredients of life are not unique to Earth. Carbon is abundant. Water appears in many forms throughout the cosmos. Organic molecules have been found in interstellar clouds, in meteorites, and in the cold reaches of space itself. None of that proves that life is common, but it does suggest that the chemistry needed for life is woven deeply into the universe. The basic letters of biology are not confined to one small planet. They belong to a much larger cosmic alphabet. So now imagine this process not happening once, but being given endless chances. Clouds collapse into stars. Stars forge heavier elements. Planets form. Some worlds are barren. Some are violent. Some remain frozen or lifeless. But among enough worlds, there may be some where the balance becomes gentle enough, stable enough, and chemically rich enough for something new to begin. A repeated chemistry. A repeated biology. Perhaps, eventually, a repeated kind of intelligence. This does not mean that life everywhere would look like life on Earth. In fact, it may not. Different histories can emerge from similar ingredients. Different climates, different evolutionary paths, different accidents, different extinctions, different pressures. The universe has room for variety as well as recurrence. But once again, the crucial point is not that every path repeats in the same way. It is that the lawful ingredients exist, the pathways exist, and the number of chances may be so large that even extremely delicate outcomes need not remain singular forever. You can think of it as a kind of cosmic patience. The universe does not seem hurried. It is willing to spend billions of years forming stars, billions more cooling planets, and perhaps billions more allowing complexity to slowly unfold. Human beings often want a single answer quickly. Is life common or rare? Is consciousness unique or repeated? Is Earth an exception or an example? But the cosmos answers more slowly. It does not resolve questions by urgency. It resolves them by scale, by number, by time, by repetition of conditions across distances too large to carry emotionally. And the deeper you follow that patience, the more unsettling and beautiful the picture becomes. Because if chemistry can repeat, and if life can arise from chemistry, and if minds can emerge from life, then in principle the ladder of repetition may rise far higher than simple matter alone. Not just atoms, not just stars, but biospheres, histories, observers, inner worlds. Of course, this is where caution matters most. A repeated kind of observer is not necessarily the same as your exact life. A repeated intelligent species is not the same as a repeated person. Even a repeated planet with oceans and continents is not the same as a repeated history. Complexity branches. Tiny differences early on can lead to immense differences later. A storm arrives one day earlier. A species migrates one valley farther. An asteroid strikes or misses. A word is spoken or left unsaid. History is exquisitely sensitive to detail. And yet sensitivity to detail does not rescue uniqueness if the universe is truly infinite. In a merely large universe, small differences would be enough to make every world feel safely singular. But in an infinite one, even extremely precise sequences may eventually recur. That is the leap that remains hard to accept. A world like Earth may not be unique forever. A history like ours may not be unique forever. And somewhere, beyond any meaningful distance, the chain of events that produced your existence may be assembled again through the repeated grammar of matter and law. Not because the universe is trying to remember you. Not because it cares in the human sense. But because given enough trials, even delicate arrangements may return. This is one reason the idea of an infinite universe so often touches something emotional in people. It takes the most private feeling we have, the feeling that this life is singular, unrepeatable, never to occur again, and places it inside a much larger frame. That frame does not necessarily destroy meaning. In some ways it intensifies it, because what is precious here can remain precious even if echoed elsewhere. A sunset does not become less beautiful because another sunset exists. Music does not lose its power because a melody could be played twice. The value of an experience is not always dependent on being the only one of its kind. Still, when the subject turns toward your own life, something in the mind resists. We want uniqueness not only as a fact, but as a form of reassurance. We want our griefs to be ours, our love to be ours, our choices to occur on a single irreplaceable stage. The possibility of repetition can feel like a quiet challenge to that instinct. And perhaps that is why it has haunted philosophers and poets long before it interested cosmologists. Because beneath the science lies a more intimate question. If life can return in some form, what does that say about identity, meaning, and the story we think we are living only once? Physics, by itself, cannot answer all of that. It can tell us about arrangements, probabilities, and law. It can tell us that complexity may arise from repeated ingredients. It can tell us that in an infinite setting, the repetition of structure becomes harder to dismiss. But the human response to that knowledge belongs partly to philosophy. And that is where our path now begins to turn. Before modern cosmology, long before telescopes revealed galaxies or mathematics described the large-scale universe, people were already wrestling with the idea that existence might in some sense return. They did not speak in the language of quantum states or entropy. They spoke in the language available to them: cycles, fate, recurrence, eternal time. Again and again, human thought circled back to one haunting possibility: that the pattern of being is not a single line, but something that repeats. And perhaps that is not surprising. Even here on Earth, long before we understand the cosmos, we live inside rhythms. Day returns, night returns, seasons return. The moon changes and changes back. Tides rise and fall. Birth and death pass through generations. Repetition is already written into the world we know best. The deeper question is whether that earthly rhythm is only local, or whether it hints at something larger, something cosmic, something embedded in reality itself. If these slow reflections help you drift a little deeper into rest, you can leave a quiet like, subscribe, or share your thoughts below. Sometimes the softest questions stay with us the longest. For now, let this part come to rest here. Matter builds structure. Structure climbs toward complexity. Complexity may, in a universe vast enough, find its way back into familiar forms. We cannot say lightly that your exact life repeats, but we can now see why the thought is not pure fantasy. It grows from the same patient logic that shapes stars and worlds. Repeated ingredients, repeated laws, vast reaches of space, vast reaches of time, and from those, perhaps, the return of patterns once thought unrepeatable. In the next part, we step away from the physics just enough to meet an older companion to this idea: the ancient and unsettling notion of eternal return, the suspicion that existence may not only continue, but in some deep sense come back. The idea of eternal return. There is a strange comfort in discovering that an idea we thought belonged only to modern science is actually much older than telescopes, older than laboratories, older even than the language of physics itself. Long before human beings could measure the age of stars or speak about entropy, quantum states, or the large-scale structure of the cosmos, they were already haunted by a quieter question. What if existence does not simply move forward and vanish behind us? What if, in some deep and unsettling way, it comes back? That thought has appeared again and again across history, almost as if it were one of those patterns the universe itself likes to repeat. Different cultures imagined it differently. Some pictured time as a great wheel. Some saw the world as a cycle of birth, decay, destruction, and renewal. Some imagined souls returning. Some imagined worlds returning. The language changed. The symbols changed. But beneath them all was a shared suspicion that reality may not be a straight road. It may be something more circular, more rhythmic, more returning than we first assume. That is where we now gently turn. We are stepping, for a little while, away from the strict language of particles and regions of space, and into a more ancient landscape of thought. Not because science has ended, but because the human mind began wrestling with recurrence long before it could explain why recurrence might matter physically. And in a way, that makes this part of the journey feel more intimate. Physics tells us what the universe may allow. Philosophy tells us what it feels like to live inside such a possibility. It makes sense that ancient people would notice repetition first. Their lives were immersed in it. Dawn returned after darkness. The moon thinned and thickened in a patient rhythm. Winter stripped the land bare, and spring restored it. Tides moved in and out. Generations followed generations. Seeds vanished into soil and rose again in forms that seemed, in their own quiet way, like resurrection. For people living close to the natural world, repetition was not a theory. It was a fact of experience. The world seemed to breathe in cycles. And when a pattern appears often enough in the world around us, the human mind naturally begins to ask whether it runs deeper still. If the seasons return, do ages return? If civilizations rise and fall, do they do so according to some larger rhythm? If the stars move in regular paths, perhaps time itself is not a line but a circle. The imagination does not need equations to begin asking such questions. It only needs attention. In ancient India, one of the most profound images of time was not linear at all. Time could be imagined as cyclical, unfolding through immense repeating ages known as yugas. These vast epochs rise and decline, not once but again and again, like breaths of a cosmos too large for ordinary human history to contain. The world is created, sustained, dissolved, and renewed. Existence is not a single chapter with a final page. It is an ongoing rhythm, difficult for the human heart to measure because its beats are so vast. Ancient Greek thought also found itself drawn to recurrence. The Stoics, in particular, entertained a vision of the universe in which cosmic history unfolds in cycles. Some versions of this idea involved a great conflagration, a cosmic fire through which the universe is periodically consumed and reborn. After this destruction, the world begins again. The same stars, the same structures, perhaps even the same events. Here the idea becomes especially haunting, because recurrence is not only seasonal or symbolic, it becomes exact. The world does not merely resemble what came before, it returns to it. You can feel the emotional force of such an idea even now. Imagine hearing that every conversation, every grief, every private regret, every small moment of kindness, every door opened, every word withheld, every life-changing accident, every ordinary afternoon, all of it will not only happen once, but happen again. Not in a loose metaphorical sense, not as a poetic echo, but again, the same, forever. It is not a thought you can hold carelessly, and yet the ancient mind kept returning to it. Perhaps that is because recurrence has two faces. One is comforting. The world returns. Spring follows winter. Night gives way to dawn. What is lost may not be lost forever. But the other face is heavier. Pain returns. Error returns. Burden returns. What you cannot bear once becomes harder still if you imagine bearing it endlessly. This double nature is part of what makes eternal return such a powerful human idea. It is not simply hopeful or frightening. It is both, depending on where you stand. There is also something deeply human in the desire for cycles. A line ends. A circle endures. A linear view of life can feel fragile because it places every moment on a path that disappears behind us forever. A cyclical view softens that harshness. It says that reality may not be a one-time departure into silence. It may turn back toward itself. It may repeat its gestures. It may not abandon what it has been. Even if such a view raises difficult questions, it also answers an emotional need. It pushes against the cold fear that everything vanishes without return. At the same time, cyclical time should not be confused too quickly with the specific idea we are approaching. Many ancient cycles were symbolic, spiritual, or cosmological without necessarily claiming that your exact life would recur in every detail. A season returns, but not the same leaf. An age returns, but not necessarily the same private thought in the same hidden room. Exact recurrence is a more severe form of the idea, and as we move forward, it becomes important to notice that distinction. Similarity is one thing, identity is another. A repeating pattern is not automatically a repeating life. Still, exactness did appear in some philosophical traditions, and it appeared because once the mind accepts a cyclical cosmos, precision begins to creep in. If the same universe is reborn from the same principles, why should it not repeat the same events? If causes return in the same order, why not effects? If the world is a lawful whole rather than a random one, perhaps recurrence is not vague at all. Perhaps it is exact. This is where eternal return begins to feel less like folklore and more like a challenge. It asks whether you could affirm your life if it returned. Not merely the broad shape of it, not a softened version of it, but the whole of it. The overlooked moments, the missteps, the sorrow you would rather not revisit, the small humiliations, the habits you never corrected, the losses that changed you, the hours you spent restless and uncertain, the joys too, the tenderness, the rare clear mornings, the unexpected laughter, the feeling of being alive in a particular body under a particular sky. Could you accept all of it again? Could you bear it? More than that, could you somehow say yes to it? That question would later be sharpened with extraordinary force by Friedrich Nietzsche, but even before we arrive there, the emotional architecture of the idea is already visible. Eternal return is not merely a theory about the universe. It is also a mirror held up to the soul. It asks not only what reality is like, but what your relationship to your own existence really is. Before we step into Nietzsche's version, it is worth lingering in the older atmosphere a little longer. Ancient cosmologies often placed humanity inside a living order rather than outside it. The world was not just a stage for human action. It was a process, an unfolding whole, one in which time, nature, and destiny were intertwined. That can feel distant to us now, because modern life often surrounds us with clocks, schedules, deadlines, and the sense that time is something spent or lost. Time becomes a resource, something managed, something consumed. But in older cyclical views, time is not so much spent as entered. One moves within it like weather. That difference matters. Linear time tends to encourage urgency. Cyclical time encourages perspective. A line presses forward. A cycle breathes. A line suggests that what is gone forever. A cycle suggests that disappearance may not be final. Neither is emotionally neutral. Each shapes the way a person imagines life, death, and meaning. And perhaps that is one reason eternal return remains so powerful even in a scientific age. It speaks to something deeper than curiosity. It touches the fear that a life might be accidental and vanish without echo. It touches the longing for pattern. It touches the suspicion that we may be living inside something larger than our local sense of before and after. Even when people reject the idea intellectually, they often still feel its pull. Now let us come closer to Nietzsche, because he transformed eternal return from a cosmological image into an existential test. Nietzsche did not present eternal return only as a technical claim about the universe. He presented it as a thought that should land personally, almost physically. Imagine, he says in one of his most famous formulations, that a demon were to visit you in your loneliest loneliness and tell you that this life, exactly as you now live it and have lived it, you will have to live again and again, innumerable times more. Every pain and every joy, every sigh and every thought, every unspeakably small or great event, all of it returning in the same sequence. It is difficult to hear that calmly, because the force of the thought does not depend on whether it is literally proven. Its force lies in what it reveals about your stance toward life. Would such a message crush you? Or would you answer that nothing more divine could be said? Nietzsche's genius was to understand that recurrence could function as a kind of spiritual weight. It tests whether you are merely enduring your life, or whether you could affirm it so completely that you would accept its endless return. That is not an easy demand. In truth, it may be one of the hardest imaginable. Most people do not move through life feeling that every detail deserves repetition. There are things we would erase if given the chance. There are years we would not want to relive. There are versions of ourselves we can barely bear to remember once. Eternal return in Nietzsche's hands becomes severe because it strips away escape. It removes the fantasy that meaning lies elsewhere, later, beyond, or after. It says, in effect, this life is the material. Can you love it? This is why Nietzsche's eternal return feels different from ancient cyclical cosmologies, even when it echoes them. He is not primarily comforting the listener with the promise that things come back. He is demanding an answer to the life already being lived. He transforms recurrence into an ethics of affirmation. To live well, under this thought, would mean to live in such a way that one could will the repetition of one's days. There is something almost merciless about that. But there is also something clarifying. Most of us drift through portions of our lives as if they do not quite count, as if a more authentic existence will begin later, after the right decision, after the right success, after the confusion passes. Eternal return interrupts that drift. It asks whether the life you are building right now is one you could stand to repeat. Suddenly, the ordinary moment matters more. The conversation matters more. The hour matters more. The hidden shape of your choices matters more. And yet, for all its severity, Nietzsche's idea also contains a strange tenderness. It suggests that life need not justify itself by ending somewhere else. It does not need to be redeemed by a distant future or an external verdict. The life itself, in all its complexity, becomes the place where meaning must be found. Eternal return presses value back into the immediate, into this act, this choice, this breath, this evening, this sorrow, this gratitude. That may be one reason the thought lingers so deeply in modern people, especially in quiet hours. It meets us where we are most vulnerable, late at night, alone with memory, aware that time keeps moving, aware that many days pass without our fully inhabiting them. Aware too that some part of us wants life to matter beyond mere survival. Eternal return turns that desire inward. It says that perhaps the measure of a life is not whether it escapes pain, but whether it can be embraced whole. Of course, one does not need to become a disciple of Nietzsche to feel the weight of the idea. Even taken gently, eternal return can function as a subtle question. If this hour were to come back, would I be at peace with how I lived it? If this season of my life were to recur, what would I want to deepen? What would I want to change? It is not necessary to hear the thought as condemnation. It can also be heard as invitation, a call to become more deliberate, more awake, more willing to inhabit one's own existence. And now, as the ancient and philosophical meanings settle around us, something interesting happens. The bridge back to science begins to appear. Because although Nietzsche's version is existential rather than physical, and although ancient cyclical cosmologies were often symbolic or spiritual, the human fascination with return did not arise from nowhere. We have already seen that modern cosmology, in its own very different language, opens the door to recurrence again, not through myth, but through infinity, not through sacred cycles, but through repeated configurations of matter. In that sense, philosophy and physics begin to circle toward each other. They do not become identical, but they begin to rhyme. One asks, what if existence returns, and how should we live if it does? The other asks, if the universe is infinite, what patterns must eventually reappear? These are not the same question, but they are close enough that the mind can feel the tension between them. The philosopher reaches recurrence through reflection on life and meaning. The physicist reaches it through law, probability, and scale. And somewhere in the quiet space between those approaches, the idea becomes more powerful than either one alone. If these calm journeys through the deeper questions of the universe help you unwind, you can leave a gentle like, subscribe, or share where you're listening from tonight. It is always grounding to know how far these thoughts travel through the dark. Human beings have long suspected that time may not simply flee forward into silence. They have imagined cycles, returns, worlds reborn, and lives tested by recurrence. Ancient cosmologies gave the idea its first grand shape. Nietzsche gave it its sharpest personal edge. And now, with all of that behind us, we are ready to ask a more difficult question. What happens when the old intuition of eternal return meets modern physics? What happens when a philosophical burden begins to resemble a cosmological possibility? That is where we go next. The physics version of eternal return. There is a moment when an old philosophical idea meets modern physics that feels almost unreal. A thought that once belonged to poets, mystics, and philosophers begins to drift into the language of cosmology. The mood changes. The symbols change. The questions become colder, more precise, more mathematical. And yet the strange shape of the idea remains the same. What if reality, under certain conditions, does not merely move forward into endless novelty? What if it also returns? Up to this point, eternal return has been something like a burden placed on the human heart, a way of asking whether a life could be affirmed if it had to be lived again. But physics approaches the same territory differently. It does not begin with suffering, meaning, or the quality of one's choices. It begins with simpler things: matter, law, probability, space, time, the number of ways a region of reality can be arranged. And from those quiet ingredients, something astonishing begins to appear. Not a moral test, but a structural possibility. Not whether life should return, but whether the universe might make repetition unavoidable. This is where the atmosphere changes, and where the story becomes a little more unsettling. Because in physics, repetition does not require memory. The cosmos does not have to remember what it once made in order to make something similar again. It only has to obey the same laws, with the same ingredients, across enough space or enough time. That is the important difference. A repeated pattern is not necessarily a cosmic act of recall. It can be a simple consequence of order unfolding over a vast enough stage. Imagine a child sitting with a small box of colored stones. There are only so many colors, only so many shapes, and only so many ways the stones can be placed on a table. At first, each arrangement seems fresh. But if the child keeps rearranging them endlessly, eventually an old pattern will return. Not because the child intended to recreate it, not because the table remembers, but because the number of possible arrangements, though large, is limited. Given enough attempts, repetition emerges naturally. In a very distant and far more elegant sense, physics begins to suspect something similar about the universe. A bounded region of space, with a certain amount of energy, may not be able to realize infinitely many distinguishable states. The exact details of this idea lead into deep territory, into thermodynamics, information theory, and quantum mechanics, but the shape of it is simple enough to feel. A region is not free to be absolutely anything. The laws of nature limit what can happen within it. They allow a vast richness, yes, but not limitless freedom. And once you combine a finite set of possible states with a reality that may contain infinite space, the logic of recurrence begins to rise almost on its own. That is the physics version of eternal return in its gentlest form. Not a mystical cycle, not a divine wheel, just repeated configurations of matter appearing across an endless cosmos. The first thing to understand is that there are two different roads by which physics can arrive at recurrence. One road comes from space. If the universe is infinite in extent, and if the same laws operate everywhere, then the same kinds of arrangements may recur somewhere else, beyond any horizon we could ever cross. The second road comes from time. If a system evolves for a sufficiently long duration through a finite set of states, then eventually it may return, or nearly return, to an earlier configuration. These are not identical ideas, but they are close relatives. One is recurrence across space. The other is recurrence through time. Both are haunting. Let us begin with space, because it is the more intuitive path. If the universe extends infinitely, then there may be infinitely many regions roughly the size of the observable universe, each governed by the same basic laws of physics. If the number of possible ways such a region can be arranged is finite, though unimaginably large, then some arrangements must repeat. Somewhere beyond measure, there may be another region with the same broad distribution of stars, the same chemistry, the same planetary architectures, perhaps even the same Earth. And if one allows the logic to continue, perhaps even the same life. This is not a certainty, and it depends on assumptions we cannot yet prove directly. But it is not empty fantasy either. It is the consequence of taking infinity seriously. Once you do that, the old human instinct to protect uniqueness by sheer improbability begins to weaken. In a finite world, improbability can secure singularity. In an infinite one, improbability simply becomes a matter of distance. There is something almost eerie in that shift. We are used to feeling that the unlikely is safe from duplication because it is so unlikely. But infinity does not care how unlikely a pattern is. If it is possible, then endless space gives it endless opportunities to appear. The rare does not remain sacred simply because it is rare. It may still occur again, unimaginably far away, hidden in another stretch of reality where the same laws quietly reshuffle the same cosmic letters into familiar words. And this is only one version of the idea. The other version, recurrence through time, carries an even stranger mood. It is connected to what physicists call Poincaré recurrence, named after the mathematician Henri Poincaré. The rough idea is this. In certain kinds of systems, if the number of available states is finite and the system evolves long enough, it will eventually return arbitrarily close to an earlier state. Not quickly. Not on any timescale a human being could emotionally understand. But eventually. Given enough time, the system wanders through its allowed configurations and can come back near where it has been before. Now, to be careful, the real universe is not a toy system in a simple box, and applying this idea to the cosmos as a whole involves deep complications. Still, the principle matters because it shows that modern physics does contain formal ways in which recurrence can happen without magic. A system does not need to be guided back. It only needs law, time, and a constrained space of possibilities. It is a beautiful and unsettling idea. The universe, left to its own lawful motion, may not move only toward the new. It may also, after unimaginable spans, circle back toward the old. At this point, the philosophical and physical versions of eternal return begin to look at one another across a narrow bridge. Philosophy asks whether you could bear the return of your life. Physics asks whether a lawful cosmos might eventually reproduce certain states again. The tones are different, but they share a common shadow. Both suggest that existence may be less singular than it feels from inside one human lifetime. Of course, physics is more modest in what it can claim. It does not tell us that your exact life definitely returns. It does not guarantee another Earth, another you, another sequence of private moments repeated without deviation. What it says is more restrained, and perhaps for that reason more powerful. It says that under certain conditions, recurrence is not absurd. It may be built into the very structure of lawful reality. That changes the emotional texture of the universe. The night sky stops being merely a field of distant objects and becomes a field of statistical potential. Stars are no longer only lights. They are signs that the same rules are at work elsewhere. Galaxies are no longer only beautiful spirals suspended in blackness. They are reminders that structure repeats. And once structure repeats on a large enough scale, the mind cannot help taking one step further. If worlds repeat, could histories? If histories, could lives? If lives, could minds like ours? The temptation is to answer too quickly. Either yes, with too much certainty, or no, from instinctive resistance. But the most honest place to stay is slower. Physics does not hand us a neat conclusion here. It opens a door. It says that if space is truly infinite, or if time unfolds long enough within a finite set of states, then recurrence becomes plausible in a rigorous sense. That is already more than enough to alter how we imagine our place in the cosmos. There is also an important subtlety here. When physicists speak of recurrence, they are often not speaking in ordinary human terms. A state, returning, may mean that the system becomes arbitrarily close to a previous configuration, not necessarily identical down to every intuitive detail. Exact sameness is a difficult thing, especially once one begins speaking about living histories and conscious experience. But near return is already a profound idea. It suggests that the cosmos may revisit itself, not through intention, but through the lawful exhaustion of possibilities. And this leads us into one of the strangest consequences of modern cosmology. In an infinite universe, recurrence is not a dramatic violation of nature. It is almost the opposite. It is nature being relentlessly itself. The same rules applied everywhere. The same matter. The same fields. The same basic principles. Nothing supernatural enters the picture. There is no secret hand, no hidden desire of the cosmos to bring you back. There is only abundance so vast that the allowed patterns of reality cannot remain local forever. That can feel cold at first. Human beings often want meaning to come from intention. We want things to matter because someone or something meant them to matter. But the universe may not work that way. A repeated world would not be repeated because it was cherished. A repeated life would not be repeated because it was chosen for return. It would return, if it returned, because law plus infinity can imitate destiny without ever becoming it. And yet that coldness has its own strange tenderness. Because it means the universe does not need myth in order to be astonishing. It does not need a supernatural script to become intimate. The same equations that govern hydrogen clouds and galaxy clusters may also open the possibility that what seems singular from here is only locally singular. Your existence, which feels so self-contained inside the borders of one life, may belong to a wider patterning of matter than any of us can comfortably imagine. There is another reason this physical version of eternal return matters. It teaches us to think differently about scale. Human emotion is calibrated to nearby consequences. We understand roads, years, cities, generations. But recurrence in physics often operates on scales that break intuition entirely. The distances involved in spatial repetition, if it exists, would be beyond not only travel but meaningful comparison. The timescales involved in temporal recurrence would likely exceed the current age of the universe by numbers so enormous that ordinary language becomes decorative rather than descriptive. These are not practical possibilities. They are structural ones. They belong not to human planning, but to the architecture of reality itself. And that distinction helps preserve a kind of calm. We are not speaking about some nearby shadow self waiting in the next galaxy. We are not speaking about a cosmic loop that will restart next Tuesday. We are speaking about what lawful infinity does to possibility. The result is less like science fiction and more like a deep background condition of existence, a hidden implication of scale. Still, once the implication is seen, it is hard to completely unsee it. The universe may be more repetitive than it looks from the inside, not repetitive in a dull sense. Not repetitive as routine, but repetitive in the way that mathematics repeats when constrained by law. Repetitive in the way a melody with only so many exact forms must eventually recur if played often enough across eternity. Repetitive in the way physical systems with limited state spaces can wander back toward themselves after immense durations. Repetitive not because creativity is absent, but because creativity itself unfolds inside structure. Perhaps that is why the physics of recurrence feels so haunting. It does not abolish novelty. There is still endless variation, endless local difference, endless branching complexity. But beneath that richness lies a quieter order, one in which patterns are not infinitely protected from return. Novelty dances on the surface. Recurrence waits below. And once that is understood, the old philosophical weight of eternal return comes back transformed. Nietzsche asked whether you could affirm your life if it returned endlessly. Physics does not ask you to affirm anything. It merely suggests that recurrence may not be impossible. But the emotional result can be similar. You begin looking at your own life differently. Not because science has proven that every moment returns, but because it has weakened the old assumption that this exact arrangement of being must exist only once. The effect of that thought depends on the listener. For some, it is terrifying. It makes suffering feel less escapable. For others, it is oddly consoling. It suggests that existence may be richer, more patterned, less lonely than it appears. A life may not be sealed inside a single occurrence. A world may not be an isolated experiment. There may be echoes beyond any possible witness. For most of us, I think, it is both. And here the story becomes still stranger, because recurrence in modern cosmology does not stop at repeated worlds or histories. It reaches into questions about observers themselves, about minds emerging from fluctuations, about consciousness arising in unexpected ways, about the possibility that somewhere in an enormous or eternal cosmos, even the appearance of an observer can repeat under bizarre conditions. That is where the subject starts to darken a little. The elegance remains, but the comfort begins to thin. Because once probability and infinity are allowed to work together long enough, the universe may produce not only familiar worlds, but also deeply unnatural kinds of repetition. Observers without histories, minds without planets, brief islands of awareness emerging from statistical accident. That is the path that will lead us toward Boltzmann brains, perhaps the strangest consequence of all. But before we go there, let this quieter version of eternal return settle in. The physical universe, taken at sufficient scale, may not be a place where the possible happens only once. It may be a place where the possible, however unlikely, is eventually tried again. Not by intention, not by judgment, not by memory, but by the simple patience of law extended across the enormous silence of space and time. If these calm explorations help you ease into rest, you can leave a gentle like, subscribe, or share your thoughts below. I always enjoy seeing where in the world these quiet journeys find people. For now, hold on to this. Eternal return is no longer only an ancient intuition or a philosophical burden. In the language of modern physics, it becomes a question of state spaces, recurrence, infinity, and repeated structure. The universe may not merely move onward. Under certain conditions, it may revisit what it has already made, or make something so similar that the distinction begins to blur. And if that is true, then the old fear and old comfort of recurrence were not simply inventions of the human imagination. They may have been, in their own way, early shadows of a cosmological truth. Infinite copies of Earth. There is a point, once you take infinity seriously, where the mind begins to resist. It can follow the logic for a while. Yes, space may be much larger than we can see. Yes, the same laws appear to hold everywhere. Yes, matter is built from repeating ingredients, and yes, patterns may return. But then the next thought arrives, and suddenly the subject stops feeling abstract. It stops feeling like mathematics floating safely out in the cold. It becomes personal in a different way. What if, somewhere beyond every possible horizon, there is another Earth? Not a symbolic Earth. Not a planet that merely resembles ours in a loose poetic sense. But a world with oceans under a familiar sky. A world with a moon bright enough to cast shadows. A world where clouds gather over continents, where tides move, where mountains rise, where rain falls into rivers that return to the sea. A world so much like this one that the differences, if there are any, become difficult to describe without first admitting how strange the whole possibility is. This is where the emotional force of cosmology begins to deepen. A repeated atom is easy to accept. A repeated star is easier still. The universe already seems full of stars made from the same elements, glowing by the same rules. But an Earth is different. An Earth feels intimate. It feels narrative. It is not just an object. It is a stage on which weather, geology, biology, memory, and history may gather. To imagine another Earth is to imagine not merely another planet, but another setting where the ingredients of a life like ours might assemble again. And yet, once we arrive here, the logic is not really new. It is only the intimacy of the conclusion that makes it feel so much heavier. If the universe is infinite, or even large enough beyond our current view, then there may be countless planets. If the laws of physics are uniform, then planets do not arise from special local magic, but from ordinary processes repeated across cosmic space. Dust gathers into disks around young stars. Gravity shapes those disks. Matter collides, settles, and slowly forms worlds. Some become gas giants. Some remain barren. Some are shattered by violence. Some drift in darkness. But among such vast numbers, there may be planets with the right chemistry, the right temperature ranges, the right kinds of star, the right delicate balance for a world like ours to emerge. There is something almost soothing in the patience of that process. Earth was not built in a moment of drama. It formed slowly, through collisions, cooling, differentiation, chemical evolution, and long intervals of change. The iron sank inward. The crust formed. Water gathered. Atmospheres shifted. Continents drifted. The world we know was not delivered all at once. It was assembled. And because it was assembled by laws rather than by exception, the idea of another Earth is no longer immediately absurd. It becomes a question of scale. The first step is to notice how little of the universe we have actually seen. The observable universe, vast as it is only the region from which light has reached us since the beginning of cosmic expansion. It is not a map of all that exists. It is a map of what has become visible from where we happen to stand. Beyond it, if space continues, there may be more galaxies than language can comfortably carry. More stars than any mind could hold in full. More planetary systems than there are grains of sand on all the shores of Earth, and then still more beyond that, and beyond that, and beyond that again. Already, even within our limited view, planets appear to be astonishingly common. Worlds seem not to be rare exceptions, but part of the ordinary output of star formation. The universe does not appear reluctant to make planets. It appears eager. It scatters them around stars with quiet abundance. Some are hot and close to their suns. Some wander far away. Some are giant and swollen. Some are rocky and modest. Some may hold thick atmospheres, or ice, or oceans hidden beneath crusts. The details vary, but the principle is the same. Matter gathers into worlds. And once worlds become ordinary, the mind is invited to take one more step. If rocky planets are common, and if stars are common, and if chemistry is common, then Earth-like conditions may not be singular. They may be rare in the narrow sense, but rarity inside infinity behaves differently than rarity in a small universe. A 1 in a trillion event feels impossible from a human point of view, but a universe with enough trials can make even extraordinary configurations feel statistically patient rather than miraculous. That does not mean Earth itself has a simple duplicate waiting nearby. The distances implied by this kind of repetition, if it is real, would be beyond anything human travel could ever meaningfully touch. This is not a story about neighboring copies hidden just beyond our galaxy. It is not a science fiction mirror world one jump away. The likely separations involved would be so vast that even calling them distances begins to feel emotionally empty. They belong less to travel and more to structure. Another Earth, if it exists, would not matter practically. It would matter philosophically. It would change what we mean by unique. You can feel that change just by sitting with a simpler version of the idea. Imagine a universe so large that there are not only many planets, but many planets with similar continents, similar climates, similar histories of bombardment and cooling, similar opportunities for oceans to gather and life to begin. They would not all be identical. Most would differ in ways large or small. But if the universe is infinite, then similarity does not have to stop at broad resemblance. Beyond some unimaginable threshold of repeated possibilities, even exact arrangements may return. That is the point at which another Earth stops being merely a romantic phrase and becomes a more serious cosmological thought. Not another habitable planet, not another blue world with clouds, but another planet with this shoreline, this moon, this atmosphere, this geologic past, this distribution of elements, perhaps even this same pattern of mountain ranges and ocean trenches and drifting plates. If the number of possible configurations in a bounded region is finite, then an infinite cosmos has room not just for cousins, but for duplicates. And duplicates are unsettling because they strain the idea of home. Earth feels singular not only because it is where we live, but because every meaningful thing in our lives has unfolded here. Every human language, every ancient migration, every forgotten animal, every work of music, every grief, every child sleeping under a roof while rain moves over the night. To imagine another Earth is to imagine another setting where that immense burden of familiarity might begin again, or perhaps already exist in another branch of space we will never touch. Of course, caution matters here. Science has not discovered another exact Earth. We have not peered through some impossible telescope and seen our own planet repeated at a distance. What we are doing is following the logic of infinity and lawful matter to its quieter consequences. If planets arise by repeated physical processes, then Earth-like planets may recur. If the state space of a region is finite, then exact or near-exact planetary arrangements may recur too. The force of the idea comes not from direct observation, but from what a sufficiently large universe would imply. And there is another layer still. An Earth is not only a collection of rocks, water, gases, and temperatures. It is also a history. It is a world shaped by accidents. Asteroids struck. Volcanoes released gases. Cells emerged. Continents separated. Ice ages came and went. Species flourished and disappeared. Dinosaurs ruled and then vanished. Mammals spread. Primates changed. Human beings arrived late, carrying language, memory, and restless thought. To repeat Earth exactly would not only mean repeating a planet's physical structure. It would mean repeating a timeline of extraordinary delicacy. At first, that seems too much. Surely a history so contingent, so sensitive to detail, cannot be repeated. Surely tiny changes would always break the chain. And in a merely large universe, perhaps that instinct would be enough to protect singularity. But not in an infinite one. Infinity is not disturbed by delicacy. It can tolerate extremely unlikely sequences because it has time and space enough to let them occur. A repeated Earth would not be easy to produce. It would be impossibly rare in the local sense. But local rarity is not the same thing as cosmic impossibility. There is a helpful way to imagine this without making it feel too mechanical. Think of a long, quiet coastline at dawn. Wave after wave reaches the sand, and no two are quite the same. Their curves differ. Their foam breaks differently. Their timing changes. Yet all are shaped by the same ocean, the same gravity, the same wind, the same geometry of shore and tide. Now imagine that coastline extending not for miles, but forever. The differences remain, but so does the possibility that some shapes return. Not because the sea intends to repeat them, Not because the shore remembers, but because law and abundance together make recurrence natural. Earth-like worlds, in this image, are like unusually delicate waves. Rare in exact form, yes, but not protected forever from recurrence if the coastline has no end. This is also where the beauty of astronomy quietly supports the feeling of the argument. The universe is already full of repeated structures on large scales. Spiral galaxies recur. Elliptical galaxies recur. Stars gather into clusters. Planets orbit stars. Rings form. Moons follow. Supernovae seed space with heavy elements, and those elements later become part of rocky worlds. The cosmos does not appear to be inventing from nothing each time. It appears to be exploring lawful combinations. That does not flatten its wonder. If anything, it deepens it. Repetition in nature is not dull. It is one of the ways beauty becomes possible. Snowflakes may differ in detail, but their crystalline logic repeats. Trees vary, but branching returns. Lightning varies, but branching returns there too. Rivers branch. Blood vessels branch. Galaxies spiral. Storm systems spiral. Nature does not seem embarrassed by recurrence. It works through it. The singular emerges from the repeated. The repeated gives rise to the intimate. So perhaps another Earth should not feel like a violation of wonder, but an expansion of it. The question is not whether repetition would make our world less meaningful. The question is whether meaning must depend on being the only one. A sunset does not lose its quiet power because sunsets happen elsewhere. A forest does not lose its depth because another forest exists. This earth, this one beneath us, remains precious because it is lived, not merely because it is numerically alone. Still, another earth changes something in us. It changes the scale of our loneliness. One of the hidden assumptions in many human thoughts is that home is singular in a strict cosmological sense. Not only beloved, but absolutely unmatched. To imagine another Earth is to loosen that assumption. Home may be precious without being exclusive. Earth may be our one reachable world and yet not the universe's only expression of such a world. In a strange way, that thought can make existence feel both less isolated and more mysterious at the same time. Because if there can be another Earth, then there can be another sky where someone looks up and asks the same questions. Another coast where tides gather under a moon. Another atmosphere carrying storms. Another world where mountains erode grain by grain into rivers and deltas. Another world where life may have emerged out of chemistry and time. Another world where beings may someday wonder whether they are alone, while never knowing that the very logic of infinity may have made them part of a pattern far wider than their own horizon. And if the thought continues, as it almost inevitably does, it becomes even more intimate. Not just another Earth with oceans and clouds. Not just another Earth with a biosphere. But another Earth at an age like ours. Another Earth whose continents resemble ours. Another Earth where life has climbed from molecules to minds. Another Earth where human-like beings, perhaps exact humans, perhaps near humans, move through history with familiar hopes, mistakes, tenderness, and fear. This is where the line between planet and story begins to blur. Earth is no longer only a world. It becomes a possible template. A pattern written in matter and law so intricate that it feels beyond repetition, and yet not beyond it if the stage is large enough. The thought is haunting precisely because it moves from geology into intimacy. Another Earth may imply another civilization. Another civilization may imply another archive of memory. Another archive of memory may imply another version of what we call history. But we are not quite there yet. For now, it is enough to stay with the planet itself. Another Earth means another ground of possibility. Another arrangement in which all the physical preconditions for a life like ours can gather. It means that the universe may contain not only vastness, but familiarity hidden within that vastness. Not only alien wonders, but echoes. There is a quiet humility in this. Earth may still be astonishingly rare from any local perspective. It may be one among numbers too large to carry with comfort. But the laws that made it do not seem private to us. They are written into the universe itself. And if the laws are not private, then the outcomes need not be private forever either. That can be heard as frightening, but it does not have to be. Another Earth does not threaten this one. It does not compete with your mornings, your memories, or the place under your feet. If anything, it enlarges the frame around them. It suggests that what happened here belongs to the grammar of the cosmos. That oceans, climates, landscapes, perhaps even life-bearing worlds, are not isolated accidents in a dead expanse, but recurring possibilities in a living physical order. There is also a gentle correction hidden in this idea. Human beings often imagine the cosmos in terms of extremes. Either we are utterly unique, or we are trivial. Either Earth is the single center of meaning, or it is nothing special at all. But the universe rarely honors such neat emotional oppositions. A thing can be special without being solitary. Earth can be precious, irreplaceable to us, and still not be the only world of its kind. Meaning does not collapse just because repetition enters the picture. In some ways, repetition may even intensify awe. It means the universe is fertile. It means the same laws that built this world can quietly build beauty elsewhere. It means that the cosmos is not only a museum of singular artifacts, but a vast field of possible homes, some strange, some familiar, some perhaps uncannily close to our own in structure. It means that the dark between galaxies may not separate uniqueness from emptiness, but one echo from another. And if you let that settle for a moment, the night sky changes again. The stars remain distant, but they begin to feel less like isolated points and more like doors into statistical abundance. Around many of them, worlds may circle. Around some of those worlds, clouds may move. On a few, perhaps extraordinarily few, water may gather into seas. On fewer still, perhaps mind may awaken. And beyond all of them, beyond even the observable horizon, the sheer extension of reality may allow some of those patterns not merely to resemble ours, but to repeat it. If these long and quiet journeys through the universe help you unwind, you can leave a gentle like, subscribe, or share where you're listening from tonight. It is always comforting to imagine these thoughts passing softly through so many different places on one very small and very beautiful Earth. For now, let this thought rest where it belongs, suspended between wonder and caution. We do not know that another exact Earth exists. But once infinity enters the picture, the possibility is no longer easy to dismiss. The same laws, the same elements, the same patient cosmic processes, extended across enough space, may produce not only other worlds, but familiar worlds. Worlds that echo this one. Worlds that test the meaning of unique. Worlds that suggest the universe may be more intimate, more repetitive, and more quietly haunted by resemblance than we ever imagined. And from there, one final step begins to wait for us. Because once another Earth becomes thinkable, another question rises almost on its own. If a planet like this can return, then what about the life upon it? What about the cities, the voices, the decisions, the forgotten afternoons, the private doubts, the exact arrangement of a mind? What about you? That is where the idea becomes hardest to hold. Infinite versions of you. Now the thought becomes difficult in a new way. Another Earth is unsettling, but it can still be held at a distance. Another ocean, another atmosphere, another quiet world under another moon. These are intimate ideas, but they remain planetary. They remain safely outside the skin. But once the logic moves one step closer, once it leaves the scale of landscapes and turns toward the scale of a person, something changes. The mind becomes more protective, more resistant, more alert. What if, somewhere in the endless architecture of the universe, there is another version of you? Not simply another intelligent being. Not merely another person with similar fears, similar habits, or a similar life. But a person with your face, your voice, your private memories, Your particular way of pausing before answering a difficult question. Your way of carrying old disappointments. Your way of feeling strangely awake at night when the world has gone quiet and the larger questions begin to press in. What if the same arrangement that became you could happen again? This is where cosmology stops feeling like a distant science and begins to touch something far more personal. Because most of us live with an unspoken certainty that whatever else may repeat in nature, we do not. A storm may resemble an earlier storm. A season may return. A species may evolve patterns that echo older forms. But a self, a person, a living center of memory and awareness, that feels singular in a deeper sense. It feels non-repeatable. And yet physics does not begin with that feeling. Physics begins with matter. Your body, for all its complexity, is made of ordinary ingredients. Carbon, oxygen, hydrogen, nitrogen, calcium, phosphorus, iron, sodium, potassium, trace elements folded into a dense and beautiful arrangement. There is nothing in the atoms themselves that announces they belong only once to you. The atoms in your bones are not marked with a metaphysical signature. The molecules in your brain do not glow with a sign that says never again. At the level of physical law, they are matter behaving as matter behaves. That does not make you simple. Quite the opposite. It is precisely because the arrangement is so intricate that the thought becomes haunting. A pile of atoms is nothing like a person. A person is not a list of ingredients. A person is structure, pattern, organization, layers of chemistry, memory, electrical signaling, biological development, emotional history, accumulated experience. What you call yourself is not merely matter, but matter arranged in a way that produces a living point of view. Still, arrangement is exactly the kind of thing physics can speak about. And once you start speaking in terms of arrangement, the old question returns in a sharper form. If the universe is infinite, and if the number of possible configurations in a bounded region is finite, then why should the arrangement called you be exempt from repetition? Why should your pattern alone be protected? Why should all the galaxies be free to recur, all the worlds be free to recur, yet your exact physical structure be granted some special immunity? That is the moment where intuition usually objects. Not because the logic is unclear, but because the conclusion feels too intimate to comfortably accept. You can hear the objection almost immediately. But I am not just matter. I am my life, my childhood, my injuries, my learning, the voices I heard growing up, the accidents that shaped me, the long chain of moments that no simple arrangement of atoms can capture. And that objection is wise. It is important, because it reminds us that repeating a body is not the same as repeating a biography. Repeating a brain is not automatically the same as repeating a lived history. Repeating structure alone may not yet answer the question of a self. So we have to move carefully here. The simplest version of the idea is that in an infinite universe, another region could contain a physical duplicate of you right now. Not someone descended from the same parents, not someone who evolved separately into broad similarity, but an exact physical duplicate, down to the microscopic arrangement of particles in a region corresponding to your body, your room, perhaps even your surrounding environment. If such duplication occurs, then from the standpoint of physical description, there could be another you sitting somewhere impossibly far away, hearing the same words, having the same thoughts, inhabiting the same inward moment. That possibility sounds almost absurd, but only because our imagination is local and our emotions are built for finite situations. Mathematics does not share that limitation. It does not ask whether a pattern feels too intimate to repeat. It asks whether the pattern is possible. If it is, then infinity changes the meaning of rare. There is a helpful way to think about this, though it only helps a little. Imagine a book written with a finite alphabet. It may be an immense book, filled with complexity, depth, contradiction, beauty. Some sentences may appear only once. Some may seem too delicate ever to recur. But if an endless library exists, filled with every possible arrangement of letters. Then somewhere there will be a page that contains the exact sentence you are reading now. Somewhere else, a page that contains the next sentence too. Somewhere still farther, an entire chapter. And with enough extension, an entire book. The complexity of the text does not save it from recurrence if the combinational space is finite and the library is infinite. A human life is far more complex than a page of text, of course. But the principle is similar. Complexity does not abolish recurrence. It only pushes it farther away. This is also where the idea branches into different levels of likeness. Another you could mean many different things, and it helps to separate them. There could be near duplicates, beings almost identical to you but not quite. There could be duplicates up to a certain point in life, after which tiny differences in history begin to diverge. There could be beings who resemble you genetically, psychologically, or biographically without being exact copies. And then there is the strongest version of the idea, the one that captures the imagination most forcefully, an exact physical duplicate, at least for a given moment, complete down to every recorded memory and emotional state. That last version is the most unsettling because it seems to threaten the uniqueness of inner life itself. If another being has your body and your brain in the same state, then by every ordinary physical account it would also have your memories. It would remember your childhood, or at least possess the same memory traces you possess. It would think it had lived your life. It would feel itself to be you. It would not experience itself as a copy. It would experience itself, quite naturally, as the original, which is exactly how you experience yourself right now. The thought becomes almost unbearable if you try to hold it too tightly, because it reveals something we normally avoid confronting. The self feels absolutely singular from the inside, but singular feeling is not necessarily the same as singular existence. Each conscious being feels central to itself. Each mind arrives at itself from within. If a duplicate existed, it would carry that same undeniable first-person certainty. There would not be one real inner life and one fake one. There would be two centers of experience, physically identical at that moment, each calling itself I. And this is where the old philosophical problem of identity quietly enters the room. What exactly makes you you? Is it your atoms? Probably not, because the atoms in your body are replaced over time in ordinary metabolic processes, and yet you still feel continuous with your past. Is it your pattern? That seems closer. The organization, the continuity of memory, the structure of the brain, the persistence of character across change. But if pattern is what matters, then a duplicate with the same pattern would have as strong a claim to your identity as you do, at least at the instant of duplication. And that is deeply strange, because common sense wants one original and one copy. It wants a hierarchy. But physics may offer no such comfort. The moment after duplication, of course, things would begin to diverge. One version of you hears a slightly different sound. Another notices a different movement. One grows tired sooner. One looks out a window, another does not. Tiny differences begin to accumulate. Histories separate. Lives branch. But for that one instant, if the physical state were exact, the two would not merely resemble each other. They would be, in structural terms, the same pattern instantiated twice. There is something both frightening and calming in that. Frightening, because it unsettles the sense that your inner life is cosmically one of one. Calming, because it suggests that consciousness may not be a fragile miracle dangling above matter, but something lawful enough to arise wherever matter is organized in the right way. If the pattern that produces awareness can occur more than once, then mind belongs not outside the universe, but fully within it. It is part of the repertoire of what matter can do. This is one reason the question of duplicates matters beyond simple curiosity. It forces us to ask whether consciousness is tied to substance or to structure. Most modern physical thinking leans, quietly or explicitly, toward structure. The same atoms arranged randomly do not think. The same atoms arranged as a living brain do. The thinking lies not in the material alone, but in the organized relation among the parts. If that is true, then your existence may depend less on special ingredients than on a special configuration of ordinary ones. And if configurations can recur, then minds can recur too. Not necessarily in a mystical sense. Not necessarily as souls returning. Not necessarily as some deep spiritual recycling of identity. Just as patterns of matter. Lawful, improbable, but not forbidden. Another you would not have to be metaphysically linked to this you in order to be real. It would only have to instantiate the same conscious structure. Of course, the more personal the subject becomes, the more the heart wants to resist the reduction. We do not like hearing ourselves described as arrangements, even if the description is scientifically serious. It can feel flattening, almost insulting, as if love, grief, memory, moral struggle, and private hope were being collapsed into mechanics. But that feeling comes partly from misunderstanding. To say that a symphony is organized vibration is not to insult the music. To say that life is organized matter is not to empty it of depth. Structure is not the enemy of meaning. Structure is often the condition that makes meaning possible. A mind is not made less wondrous because it obeys laws. If anything, it becomes more wondrous. It means the universe is capable of arranging ordinary atoms into awareness, reflection, tenderness, shame, longing, imagination, and the ability to sit awake wondering whether one's life might repeat. The lawful nature of consciousness does not cheapen it. It places it among the highest expressions of physical order. And perhaps that is the gentlest way to hold this idea. Not as a threat to your uniqueness, but as a widening of what the universe may be able to contain. If another version of you exists somewhere, that does not make your life here unreal. It does not dilute your joys or erase your sorrows. This you still loves, fears, chooses, regrets, remembers. This life is still lived from the inside, and that interiority is not made hollow by the existence of echoes elsewhere. Still, another question rises almost immediately. If there is another you, is it really you? The answer depends on what one means by really. If by you, we mean numerical identity, one single ongoing stream of consciousness, then no. A duplicate elsewhere would not literally continue your stream of awareness. When you fall asleep tonight, you will not wake up in the body of a cosmic twin far beyond the observable universe. Their pain would not be felt by you. Their thoughts would not migrate into your skull. They would be their own conscious center. But if by you, we mean the total pattern that constitutes a person at a given moment, then yes, in another sense, they would be you. They would think your thoughts, hold your memories, fear your fears, carry your emotional geometry. And perhaps that is why the question refuses to settle. Our ordinary concept of self may contain two ideas at once, continuity and pattern, and duplicates pull those ideas apart. Continuity belongs to the stream. Pattern belongs to the form. Most of the time these overlap, so we do not notice the distinction. But in thought experiments like this, the overlap breaks. A duplicate shares the form but not the stream. That is enough to create a deep unease. Which is more essential? The shape of a mind, or the unbroken line of its experience? No final answer is waiting quietly at the bottom of that question. Philosophy has wrestled with it for a long time, and perhaps always will. But cosmology adds something new. It says this is not merely a puzzle invented in classrooms. Under certain assumptions about the universe, it may be a consequence of physical reality. There is also a softer version of the idea that many people find easier to inhabit. Perhaps exact duplicates are too severe a thought. Very well. Then imagine instead that in an infinite universe there are not just one or two versions of you, but infinitely many variations. Some very close, some only faintly related. In one, your life diverges at a small decision. In another, a conversation goes differently. In another, you never meet someone important. In another, you leave a place earlier or stay longer. In another, the same childhood unfolds but adulthood bends along a different path. The further out one goes in possibility space, the more variation blooms. This kind of branching imagination is not exactly the same as the idea of parallel universes in the many worlds interpretation of quantum mechanics, though people often blend the two together. Here, the point is simpler. In sufficiently vast space, not just one precise arrangement but a whole family of near arrangements may recur. There may be regions where almost you lives a life almost like yours. A familiar face under a slightly different history. A familiar mind carrying a slightly altered burden. This can be interpreted in many ways emotionally. For some, it feels sad, because it reminds them of roads not taken. For others, it feels comforting, because it suggests that the self is not sealed into one brittle path. For still others, it feels almost dreamy, a cosmic extension of all the possibilities that hover around ordinary human regret. Somewhere, one imagines, another version made the other choice. Another stayed. Another left. Another forgave. Another asked the question. Another remained silent. Strictly speaking, cosmology does not owe us these consoling narratives. The universe is not obliged to arrange itself into emotionally satisfying counterfactuals. But the general logic of repetition does allow something like a landscape of near duplicates. And once that landscape is admitted, the notion of one unique self standing alone in all of reality becomes harder to defend. Even so, it is important not to romanticize this too quickly. An infinite collection of versions does not rescue us from the need to live this version of our life. You do not get to borrow peace from another branch of possibility. You do not get to send your grief away to a better outcome elsewhere. This life remains yours to inhabit. Another you, if such a being exists, would not carry your responsibilities for you. They would only carry their own, even if those responsibilities looked startlingly similar. In that sense, the idea of duplicates does not reduce the urgency of existence. It sharpens it. This version of you still has to choose. This version still has to live through the consequences. This consciousness, here, still feels what it feels. Whether there are echoes elsewhere matters cosmologically, but not as an escape from the local reality of being alive. And perhaps that is one reason the thought can become unexpectedly peaceful after its first disturbance has passed. You realize that uniqueness may not be the only ground of meaning. Perhaps the value of a life does not come from being cosmically unrepeatable. Perhaps it comes from being lived sincerely from the inside. A poem does not lose its force because another copy exists. A song is not made empty because it can be played again. The reality of experience lies in its occurrence, not only in its exclusivity. What matters here still matters. The private pain still hurts. The quiet beauty still softens the heart. A hand held in kindness is not less meaningful because another similar hand may be held somewhere unimaginably far away. The local truth of experience remains intact. In fact, it may become more mysterious, because now it seems to belong to a universe capable of echoing even its most intimate patterns. If these long, quiet explorations help you settle more deeply into the night, you can leave a gentle like, subscribe, or share a thought below. It is always grounding to know where in the world these questions are being heard. For now, let this idea rest where it naturally belongs, somewhere between science and self-recognition. If the universe is infinite, then the arrangement called you may not be protected forever from recurrence. There may be exact duplicates, near duplicates, or whole families of almost yous spread across distances too large for the mind to fully picture. They would not replace you. They would not continue your single stream of awareness. But they would challenge the old certainty that a self must occur only once in all of reality. And once that certainty begins to loosen, another even stranger question begins to approach. If a mind like yours can reappear because matter arranges itself lawfully under the right conditions, then must that mind always arise inside a full world, with a childhood, a planet, a history, and a sky? Or could awareness emerge in far stranger ways, out of fluctuation alone, briefly, improbably, without the long story that normally gives a mind its place? That is where the subject becomes colder, darker, and far more bizarre. That is where Boltzmann brains begin. Boltzmann brains and random consciousness. There is a point in this journey where the universe begins to feel less like a home and more like a puzzle too large to hold all at once. Up to now, the idea of repetition has still carried something familiar. Another world, another Earth, another version of you, perhaps unimaginably far away, but still woven into a full setting, a full history, a full sequence of causes stretching backward through time. Even when those ideas felt unsettling, they remained understandable in a human way. They still belonged to stories. A planet forms. Life begins. A mind slowly emerges inside a body and a world. But now we arrive at a much stranger thought. One that does not grow gently out of stars, planets, and biology, but out of probability itself. What if a mind could appear without the world that normally gives it meaning? What if awareness, under extreme and improbable conditions, could emerge not from a childhood, a planet, a species, and a long chain of events, but from a brief statistical accident in the fabric of a vast universe? Not a whole civilization, not a whole history, just a single conscious observer, appearing for a moment with memories that feel real, thoughts that feel continuous, and no actual past behind them. This is the idea of the Boltzmann brain, and it may be one of the strangest concepts modern cosmology has ever produced. It sounds almost like science fiction when heard for the first time, but it did not arise from a desire to invent something dramatic. It arose from an attempt to understand order, disorder, and the quiet mathematics of probability in an enormous cosmos. Its roots go back to the 19th century and to one of the great minds of statistical physics, Ludwig Boltzmann. Boltzmann was trying to make sense of entropy, one of the deepest ideas in physics. Entropy is often described as disorder, though that word is only a rough guide. More precisely, entropy has to do with the number of microscopic ways a system can be arranged while still appearing the same at a larger scale. A hot gas left alone tends to spread out. Ice left in a warm room tends to melt. Structures dissolve more easily than they assemble. The universe, in many ordinary situations, seems to move from more ordered states toward more probable, more disordered ones. This is why it is easier for a glass to shatter than to reassemble itself. Easier for cream to mix into coffee than for mixed coffee to spontaneously separate itself back into black liquid and white cream. The movement toward higher entropy feels natural because higher entropy states are statistically more common. There are simply more ways for things to be mixed than unmixed, more ways for energy to be spread out than neatly concentrated. Boltzmann understood that what we call order may be a temporary and improbable island inside a wider sea of disorder. And once one begins thinking this way, a haunting possibility emerges. If a system is large enough, old enough, or given enough chances, then even very unlikely low entropy fluctuations may happen from time to time. A small pocket of order could emerge spontaneously out of a more disordered background, not because nature prefers it, but because probability allows it. At first, that does not sound too alarming. The world is already full of fluctuations. Molecules move unpredictably. Tiny local changes happen constantly. But if one scales the idea up to the largest levels of cosmology, it becomes far stranger. Suppose the universe, or some large region of it, exists for an unimaginably long time in a mostly disordered state. In such an immense stretch of time, statistical fluctuations are not limited to tiny rearrangements. In principle, larger and larger unlikely structures could eventually appear. And here the old intuitive picture begins to crack. If it is possible for a fluctuation to produce a whole orderly universe like the one we see, that would be astonishingly unlikely. But perhaps, in an eternal enough setting, not impossible. Yet to produce only a small pocket of order, a much smaller fluctuation would be needed, and smaller fluctuations are vastly more probable than larger ones. This means that if the universe can fluctuate into ordered states at all, it may be far more likely to fluctuate into something minimal than into something grand. And what is the minimal ordered structure required for an observer? That is the chilling question. A full universe with billions of galaxies, stars, planets, and a long evolutionary history is one way to produce a conscious observer like you. But from a purely statistical point of view, that may be extravagantly expensive. It requires an enormous amount of low-entropy structure. If all that is needed for an observer to exist for a brief moment is a functioning brain, complete with the appearance of memories and experiences, then a single brain fluctuating into existence would be vastly more probable than an entire cosmos fluctuating into being around it. That hypothetical observer is what people call a Boltzmann brain, a mind appearing out of chaos, complete enough to be conscious for an instant, perhaps even complete enough to think it remembers a whole life, even though that life never actually occurred. It is difficult to sit with that idea for long because it reaches directly into our trust in reality. We do not like the suggestion that memory could feel perfectly real and still have no history behind it. We do not like the possibility that a conscious point of view could emerge fully furnished with false continuity. And yet the logic of statistical fluctuation pushes in exactly that direction if one is not careful about the cosmological picture being used. To feel the shape of it more gently, imagine a stormy sea. Across its surface, waves rise and vanish continuously. Tiny temporary forms appear and disappear. Now imagine that sea not for an hour, but for an unimaginable duration. Given enough time, rarer shapes may briefly form. Not often, not meaningfully, but eventually. A crest here, a pattern there. And if one lets the imagination go too far, it becomes possible to picture something extraordinarily delicate emerging not because it belongs there in a lawful developmental story, but because chance, given enough opportunities, can briefly imitate structure. A Boltzmann brain is chance imitating structure at the level of awareness. Of course, real physics is not simply a poetic ocean. A brain is an immensely specific physical system. It is warm, chemical, electrical, biological, dynamic. It depends on exquisite organization. The odds of such a thing fluctuating into existence from a high-entropy background are so absurdly tiny that ordinary human language collapses in trying to describe them. But the key point is not that such a fluctuation is likely in everyday terms. It is that in certain cosmological models, if time is effectively unbounded, even absurdly tiny probabilities may come to matter. Given enough time, the improbable stops being safely negligible. This is why Boltzmann brains are not treated mainly as a prediction that we should expect to encounter one, or become one, in any practical way. They are treated as a warning sign in cosmology. A test of whether a model of the universe makes sensible observers like us more probable than absurd, isolated ones. If a cosmological theory implies that most observers should be Boltzmann brains rather than beings who arose through a long evolutionary history in a stable universe, then the theory has a serious problem. And that problem cuts deep, because we are observers. If a theory says that the overwhelming majority of observers are random, short-lived minds with false memories, then why should we assume we are not among them? Why trust our memory of a childhood? Why trust our sense of a world extending beyond the present moment? Why trust the stars, the earth, the past, or the chain of causes that seems to connect them? The Boltzmann brain problem is frightening not because it tells us this is likely in our actual universe, but because it exposes how fragile our assumptions become when probability is stretched across extreme scales. Fortunately, most physicists do not believe we are Boltzmann brains. And the reason is important. The concept is not presented as the conclusion of cosmology, but as a challenge that good cosmological theories must avoid. A viable picture of the universe should explain why ordinary observers, ones produced by stars, planets, chemistry, biology, and long histories, are the typical kind, not the rare kind. If a theory instead predicts that disembodied fluctuation minds dominate, then something in that theory is probably incomplete, misapplied, or wrong. Still, even as a problem rather than a destination, the idea leaves a mark on the imagination. It asks us to take seriously the possibility that consciousness, in principle, might not require the whole beautiful story we usually attach to it. It might, in the most brutal statistical sense, arise in isolated fragments under strange conditions. That does not mean it usually does. It does not mean that life, evolution, and biology are irrelevant. In the universe we know, all evidence points to minds arising through those rich lawful histories. But the Boltzmann brain thought experiment reminds us that the space of physical possibility may be much stranger than the space of ordinary experience. There is also a philosophical sharpness to this idea that makes it linger. A Boltzmann brain would not know it was one. If it appeared with a full pattern of memory, it might feel certain that it had lived an ordinary life. It might feel the weight of a past that never occurred. It might look out at an apparent world that was not truly there except as part of the fluctuation. It might even wonder whether reality is trustworthy. And then, in the next moment, vanish. That image is almost unbearably lonely. A mind with all the inward texture of personhood, but without the world that normally nourishes and anchors it. Awareness stripped down to a brief statistical event. A self without roots. Memory without history. Perception without an enduring cosmos behind it. Perhaps that is why the concept feels colder than the earlier parts of our journey. Another Earth still belongs to a universe rich with continuity. Another you still belongs to a body, a world, a timeline. But a Boltzmann brain is continuity severed. It is consciousness reduced to the minimum necessary for an observer-like moment to exist. No childhood, no species, no long planetary past, only the appearance of those things compressed into a passing configuration. And yet, precisely because it feels so wrong, the idea tells us something valuable. It tells us that cosmology must respect not just the existence of observers, but the kind of observers we plainly are. We are beings embedded in lawful history. We see fossils, stars, background radiation, biological continuity, geological layers, and the steady web of cause and effect. The fact that our experience is coherent across time is itself evidence that the universe is not best described as a machine mostly producing random isolated minds. Good cosmology must preserve that coherence. This is one of the quietly beautiful things about science. It is willing to follow an idea into bizarre territory if that is what the logic demands, but it is also willing to treat the resulting absurdity as a clue. Boltzmann brains are not embraced because they are exciting. They are taken seriously because their absurdity teaches us where our cosmological models become unstable. They are a signpost pointing toward the need for deeper understanding. There is another layer to the idea as well, one that touches on the earlier theme of recurrence in a particularly eerie way. Boltzmann brains are a kind of repetition, but a distorted one. They are not the graceful recurrence of a full life or a full world. They are the statistical shortcut version, a mind appearing without the long developmental ladder beneath it. In that sense, they are a warning about what happens when probability is allowed to substitute for history. The universe may be able to imitate the endpoint of a process without reproducing the process itself. And that distinction matters deeply. A naturally evolved brain on Earth is the result of stars dying, elements forming, planets cooling, chemistry complexifying, life emerging, species changing, nervous systems developing, cultures forming, and individuals growing inside families and environments. That is a lawful chain rich with continuity. A Boltzmann brain, by contrast, would skip the chain and arrive at the endpoint directly by chance. It would have the structure of memory without the causal path that memory is meant to represent. That makes it a deeply unnatural observer, even if not a physically impossible one. In a quiet way, this restores some appreciation for the ordinary reality we inhabit. The fact that our world is lawful, layered, and continuous is not trivial. It is extraordinary. We wake each day in a universe that seems to remember itself. Causes lead to effects. Seasons follow. Children become adults. Stars age. Rocks record ancient climates. Galaxies carry the marks of cosmic history. Even our own bodies are archives of time. We are not isolated flickers appearing from nowhere. We belong to a long unfolding. The Boltzmann brain idea makes that belonging feel precious by contrast. It reminds us that consciousness is richest when it is embedded. Memory matters because it links us to genuine continuity. Identity matters because it is shaped by history, not merely by one frozen arrangement. A mind makes fuller sense when it arises from a world rather than from statistical accident alone. In that way, the concept is not only disturbing, it is clarifying. It teaches us what we would lose if awareness were severed from the story that gives it depth. And still, the physics behind it remains serious enough that it cannot simply be laughed away. In discussions of de Sitter space, vacuum fluctuations, and the long-term fate of expanding universes, questions like this remain relevant. If the cosmos expands forever into a thin, cold state, what kinds of fluctuations are still allowed? If horizons limit the information content of regions, how does one think about recurrence there? If quantum fields persist indefinitely, what counts as a likely observer over extreme timescales? These are not casual questions. They sit near the foundations of cosmology, where our theories are still incomplete and where intuition often fails. That is part of why the Boltzmann brain remains so haunting. It is not a silly fantasy pasted onto science from outside. It is a real tension arising from within science itself. A pressure point where thermodynamics, cosmology, and the philosophy of observation all meet. A place where the question, what kind of observer are we, becomes inseparable from, what kind of universe is this? There is a more human side to it too. Many people, when they first hear of Boltzmann brains, experience a brief vertigo. Not because they truly believe they are one, but because the concept temporarily loosens the ordinary confidence with which we move through life. It reveals that trust in the world is not purely logical. It is also existential. We live as beings who assume continuity, who assume a past, who assume that our memories refer to real causes and not to random assembly. Usually this trust is quiet, almost invisible. The Boltzmann brain thought experiment makes it visible by threatening it. And once visible, that trust can even become beautiful. Because the world does seem coherent. The stars do not flicker in and out as isolated fantasies. Physics done today agrees with physics done yesterday. Records converge. Histories interlock. Different lines of evidence support one another. The universe presents itself not as a broken slideshow of disconnected moments, but as a woven fabric. The mere fact that we can study it, test it, and find deep consistency is itself evidence against the lonely chaos imagined by the Boltzmann brain scenario. So the proper response to the idea is not panic, but perspective. It is a reminder that cosmology must earn our confidence by explaining why coherent worlds like this one are natural, and why observer-like fluctuations are not the dominant story. It is a reminder, too, that when we talk about recurrence, we must distinguish between meaningful recurrence and pathological recurrence. Another Earth is one kind of return. Another you inside a genuine world is another. A lone fluctuation mind is something else entirely. It is recurrence stripped of continuity, imitation stripped of history. And maybe that is why it feels so emotionally thin compared with the earlier ideas. A repeated life still allows love, weather, childhood, memory, and place. A Boltzmann brain allows only the appearance of these things. It is a counterfeit history compressed into an instant, a shadow of a life, not a life unfolding. Still, shadows matter in thought, because they help define what the real thing is. By imagining a mind with only apparent continuity, we better understand the value of genuine continuity. By imagining memory without history, we better understand why history matters. By imagining a self without a world, we better understand how deeply selfhood depends on world. There is a quiet lesson there. Consciousness is not just a spark. It is also a context. A mind is not richest when it simply exists. It is richest when it belongs to a body, a planet, a language, a history, a chain of causes. The fullness of awareness is not only that it occurs, but that it occurs somewhere, after something, because of something. That may be why the idea of eternal return still remains more emotionally compelling than the Boltzmann brain. Eternal return speaks of life coming back. Boltzmann brains speak of awareness without life. One preserves the story, the other bypasses it. And for beings like us, story matters. If these slow, strange reflections help you settle into the night, you can leave a quiet like, subscribe, or share your thoughts below. It is always a comfort to know how many minds are wandering through these questions together, each from their own small corner of one very ancient world. For now, let the coldness of this idea soften at the edges. The Boltzmann brain is not a prediction you need to fear. It is a signpost in cosmology, a strange consequence that tells physicists which pictures of the universe may be incomplete. It reminds us that not all recurrence is equal. Some forms of repetition preserve history and meaning. Others only mimic them. And that difference will matter greatly as we move forward. Because the next question is even more intimate. If the universe can, in principle, repeat configurations, and if not all repetition is equal, then what should we say about the return of a full life? Not a lone mind flickering in and out of chaos, but a real sequence. A genuine history. A world, a body, a stream of days, and a person living them through. Could your exact life ever happen again? And if it could, what would that really mean? Will your exact life ever repeat? After wandering through infinite space, repeated worlds, repeated selves, and even the cold and unsettling idea of Boltzmann brains, we arrive at the question that was waiting quietly behind all the others from the beginning. Could your exact life ever happen again? Not a life that merely resembles yours. Not a nearby variation, not another person with your face but a different history, not a mind with borrowed memories appearing briefly out of statistical noise. Something stronger than that. The same life. The same chain of mornings and nights. The same parents, the same childhood rooms, the same private fears, the same injuries, the same little joys that barely seemed important at the time. The same sequence of choices, the same turning points, the same forgotten hours that seemed ordinary while they were happening and only later became part of the shape of who you are. Could that whole story ever repeat? This is where the subject becomes hardest to hold, because the question no longer belongs only to cosmology. It belongs to memory, to identity, to that very human feeling that your life is made not only of matter, but of time. Even if another version of you could exist somewhere, that is one thing. But the return of your whole life, step by step, cause by cause, detail by detail, feels like something else entirely. It feels almost too delicate, too contingent, too precise to be placed inside the same conversation as stars and entropy and infinite space. And yet, if we have learned anything on this journey, it is that scale changes the meaning of precision. A thing can feel impossibly fragile and still not be protected forever from recurrence if the universe is large enough, old enough, or patient enough. Rarity matters, but rarity is not the same as impossibility. The important question is not whether your life is intricate. It clearly is. The important question is whether the laws of nature forbid its exact recurrence. And if they do not forbid it, then we are left with a quieter and more haunting possibility. That what feels singular from inside your own stream of time may not be singular in the full architecture of reality. To approach this honestly, we have to separate two different meanings of repetition. One meaning is repetition across space. Somewhere in an infinite universe, another region might exist in the same physical state as this one, or close enough to it that the same history unfolds there. The other meaning is repetition across time. The very same region, or the very same system, may eventually evolve back into a state identical, or almost identical, to an earlier one after an immense stretch of duration. One is like finding the same pattern written elsewhere. The other is like the same page being written again after an unimaginable interval. Both versions matter. Both suggest that your life may not be cosmically protected from return. But they do so in different ways, and the difference matters because it changes what, again, really means. Let us begin with space, because it is easier to picture, even if only barely. If the universe is spatially infinite, or simply vast enough beyond our horizon, then there may be regions where the physical arrangement of matter matches ours exactly. Not approximately, but exactly, at least within some bounded volume. If the match includes not only your body but your surroundings, your planet, your history-bearing environment, then from that point onward the same history would unfold, assuming the laws and conditions remain the same. In that sense, your life would not have to repeat in the future in order to repeat. It could be happening elsewhere already. That possibility changes the emotional feel of recurrence. It removes the idea of waiting. Your life would not need to come back after the death of the universe or after some great cosmic reset. It could exist as one of many instantiations of the same lawful story, spread across space rather than across time. Somewhere beyond all reachable distance, another region may contain this same hour, the same breath, the same sentence, the same listener wondering whether anything like that could really be true. But there is another path to recurrence, and in some ways it feels even stranger because it does involve time in a more direct sense. This is the path suggested by recurrence theorems, especially the broad family of ideas connected to Poincaré recurrence. The rough principle, stated gently, is that a finite system evolving under certain conditions through a finite space of possible states will eventually return arbitrarily close to an earlier state if given enough time. The phrase, arbitrarily close, matters, because physics is careful here. It does not casually promise intuitive exactness. But the larger lesson is still remarkable. A lawful system need not move forever into the wholly new. If it has a bounded structure of possibilities, then deep time allows return. Now, the universe as a whole is not a simple classical system in a box, and applying recurrence ideas to cosmology requires great caution. Expansion, gravity, quantum effects, horizons, and the unclear long-term nature of reality all complicate things. Still, the recurrence picture remains powerful because it provides a formal way of thinking about how even extremely complex states might reappear without requiring anything mystical. Not because the cosmos remembers them, not because time is secretly circular in a mythic sense, but because finite possibilities explored long enough allow revisitation. This is often where people feel a very natural resistance. Surely the exact repetition of a life would require more than a repeated physical state. It would require the same whole history leading into that state, the same childhood, the same chain of causes, the same world. If you simply recreate a moment, perhaps you recreate the structure of a mind complete with memory, but is that the same as the life having truly happened again? That is an important objection, and it helps us see that exact life can mean at least two different things. One meaning is structural. At a given moment, there is a conscious being in precisely the same physical and mental state as you, including all the same memories and self-understanding. In that sense, your life is present again because the current endpoint is present again. Another meaning is historical. Not only the present state, but the whole causal pathway that led to it has unfolded once more. In that stronger sense, your life has genuinely been lived again, not merely reconstructed in a snapshot. The second meaning is obviously much harder to secure. A repeated moment is already astonishing. A repeated causal history is far more delicate. Yet even here, infinity remains patient. If the same region of space can recur exactly, then the same history can recur too, provided the repeated region is large enough to include all the causes relevant to that history. And if the same lawful universe exists in many copies, or if the same states recur over deep enough time, then the chain itself may not be protected from return either. This is the point where human intuition often loses its grip, because human intuition treats history as unrepeatable almost by definition. We think of the past as gone because it has passed, and this is perfectly sensible at the local scale where our lives unfold. A spoken sentence vanishes into memory. A child grows and does not become that child again. A specific winter leaves, and though another winter comes, it is not that winter. Ordinary life trains us to understand time as irreversible biography. We move through it and cannot walk backward. So the idea that history itself might recur feels like a category mistake. But physics does not always honor the emotional grammar of daily life. The same laws that make time feel one-directional to us at the scale of memory and entropy may still allow recurrence at scales so vast that everyday intuitions no longer guide us safely. Irreversibility in practice is not always the same as impossibility in principle. A broken glass does not reassemble on the kitchen floor, but that does not mean the microscopic laws have forbidden every imaginable path back to an earlier state. It means the path is so statistically remote that for all practical purposes it never occurs. Scale and probability do the work. Your life may belong to that same category. Not impossible to repeat in principle. Only so unimaginably improbable that inside ordinary human terms it feels sacredly singular. And that distinction is everything. Because once we admit, improbable but not forbidden, the question changes shape. We no longer ask whether the universe cares enough to bring your life back. We ask whether the universe is large enough, or long enough, to allow such a rare configuration and such a rare history to happen again. That is a colder question, but also a more honest one. It shifts recurrence out of the language of destiny and into the language of law. There is a useful analogy here, though only a partial one. Imagine an immensely long piece of music written under strict formal rules. The melody can vary, the harmonies can deepen, the rhythm can wander, but the space of exact possible performances, though vast, is finite if the duration and notation are bounded. If that music were played not once, not a million times, but endlessly, then eventually an exact performance might return. Not because the musicians wished to honor the old one, not because they remembered it, but because the combinational space, however large, is not protected forever from recurrence. A life is more complex than a piece of music, much more complex. But it too is a structured unfolding within law. Your body is not free to violate chemistry. Your brain is not free to violate physics. Your world is not free to violate causation. This does not reduce the richness of living. It only means that richness happens within structure. And structure, when combined with enough space or enough time, opens the door to repetition. Still, we have to be careful not to drift too quickly into certainty. There are real unknowns here. Is space truly infinite? Is the number of physical states in a relevant region finite in the required way? Does the global structure of the universe permit recurrence? How should quantum mechanics be understood at the deepest level? What does exactness mean when one includes every causal detail that matters to a life? These are not settled matters. A calm answer must remain a humble one. Yet uncertainty does not empty the question of its force. If anything, it makes the question feel more alive. We stand in a universe that may be structured in such a way that exact recurrence is possible, while not yet knowing whether the structure is large or old enough, or simple enough in its deepest rules, to make that possibility real. The result is a kind of suspended wonder. A life may not be guaranteed to repeat, but it may also not be guaranteed uniqueness in the absolute sense we casually assume. What would it mean, emotionally, if your exact life could repeat? At first the thought lands heavily. Every pain again. Every mistake again. Every hour of uncertainty again. Every private loss again. The burden of eternal return, in its philosophical form, comes rushing back. But then another feeling begins to arrive beside it. If your life could repeat, then your small moments matter in a different way. The ordinary afternoon matters. The quiet kindness matters. The hidden resentment matters. The path you take through a difficult season matters. Not because the universe is judging you, but because existence itself may be richer and more patterned than the one past story we often tell ourselves. There is also a softer possibility. Perhaps exact recurrence, if it exists, is so remote that it does not function as pressure but as perspective. Your life may be one pattern among many lawful patterns. Unique here, meaningful here, and perhaps not alone in all of reality. That does not diminish it. It simply means meaning may not depend on numerical solitude. A melody is still beautiful even if it can, somewhere, be played again. This is important, because many people instinctively fear that repetition would cheapen life. If there are infinite copies, does anything matter? If your exact life can recur, does choice lose its seriousness? But that conclusion does not really follow. Repetition elsewhere does not drain the reality of experience here. Another sunset does not cancel this sunset. Another act of love does not erase this one. Another version of your life would not absorb your responsibility for this version. This moment still belongs to you, even if the cosmos is large enough to echo it. And perhaps that is one of the deepest lessons buried inside all of this. The value of a life may not rest on being cosmically unrepeatable. It may rest on being inhabited, lived from within, felt as real. This particular stream of awareness, this version of your joys and burdens, still matters fully on its own terms. Recurrence does not empty local reality. It only complicates the larger frame around it. There is also a hidden asymmetry worth noticing. We often imagine recurrence in terms of dramatic events. Great choices, major losses, turning points, crucial conversations. But if your exact life repeats, then what repeats most fully are not the dramatic moments alone. It is the texture, the unnoticed air in a room, the way fatigue changes your thoughts, the silence before a phone rings, the particular shade of evening on an ordinary wall, the rhythm of familiar footsteps in a hallway, the little things that seemed too small to matter while they were happening and that, together, became the actual fabric of living. That is why the question is so emotionally powerful. It is not really about grand cosmic spectacle. It is about whether the quiet shape of your life belongs only once to reality or whether it could, under conditions vast enough, return in full. The thought touches us because we know life is made mostly of small moments. To imagine those recurring is more intimate than to imagine galaxies recurring. And here, perhaps, the sharpest distinction of all emerges. There is a difference between could and will. Physics may allow exact recurrence in principle without giving us reason to expect it in any humanly meaningful sense. The timescales may be beyond absurd. The distances may be beyond any imaginable relevance. It may be true that your exact life can recur and also true that, for all practical purposes, you and everyone you know will live as if it never does. Structural possibility is not the same as existential immediacy. This may sound disappointing at first, but it actually preserves something important. It lets the idea remain profound without turning it into a crude slogan. We do not need to pretend that cosmology has proven the literal immediate return of individual lives. It has not. What it has done is more subtle and, in its own way, more interesting. It has destabilized the easy confidence that exact personal history must occur only once in all of reality. It has shown that, in an infinite or recurrence-friendly cosmos, even a life may be the kind of thing that can return. That is enough to change the mood of existence. It means that time may not be a one-way corridor quite as simple as it feels. It means that a life may be both local and, in some deeper structural sense, repeatable. It means that the old human intuition of eternal return may not have been mere poetry, even if poetry found it first. Physics has not sanctified it, but it has given it a foothold. And once that foothold exists, another question follows with quiet inevitability. If your exact life could happen again, would that change how you live this one? Not because you are trying to optimize for some cosmic rerun. Not because a philosopher or a demon is standing over your shoulder demanding affirmation. But because the possibility of recurrence makes the local texture of being feel a little less disposable. A little less easy to postpone. A little less safe to sleepwalk through. This is where the scientific and philosophical paths begin to converge one last time. Science says your life may not be protected from recurrence. Philosophy says then perhaps you should live it in a way you could stand to meet again. One speaks in terms of state spaces and infinity. The other speaks in terms of courage, acceptance, and the difficult art of saying yes to life. They are not the same voice. But they may be looking at the same abyss from different sides. If these quiet journeys through the deeper edges of science and existence help you settle more deeply into the night, you can leave a gentle like, subscribe, or share a thought below. It is always grounding to know how many people are listening from their own singular, and perhaps not entirely singular, corner of the universe. For now, let the question remain open in the calmest possible way. Could your exact life ever repeat? We cannot say with certainty that it must. But neither can we say, with the same easy confidence as before, that it cannot. In an infinite cosmos, or in a lawful reality explored across incomprehensible spans of time, even a life may be the kind of pattern that returns. Not often. Not nearby. Not in any way that ordinary human life can use. But perhaps in principle. Perhaps structurally. Perhaps somewhere beyond the reach of every road and every memory. And if that is true, then one last step remains. Not whether recurrence is possible, but what to do with that knowledge. How to place your life, your choices, your small private hours, inside a universe where meaning does not depend on being the only occurrence, yet still feels urgent and real. How to live inside infinity without being diminished by it. How to meet the possibility of return without fear or false comfort. That is where we go next. Living in an infinite universe. By now, the universe may feel quieter than it did at the beginning. Not smaller. Not simpler. But quieter in that strange way deep ideas sometimes become quiet after they have passed through the mind long enough. At first, they arrive with force. Infinity. Eternal return. Repeated worlds. Repeated lives. Boltzmann brains. Statistical recurrence. Each concept enters almost like a disturbance, a ripple spreading across the ordinary assumptions we carry without noticing. But after a while, the ripples widen. The force softens. And what remains is not shock, but perspective. That is where we are now. We began with a very human feeling, the feeling that life moves in one direction and only once. We experience time as a current. Memory trails behind us. The future waits in front of us, and the present keeps slipping through our hands. From inside that experience, a life feels singular almost by definition. It feels unrepeatable because it is being lived from within, and from within, everything is one time only. Then the scale widened. We stepped beyond daily life and looked outward, first at the vastness of the universe, then at the possibility that the universe may not merely be large, but infinite. And once infinity entered the picture, old certainties began to loosen. If space has no end, then patterns may not remain unique forever. If matter is built from repeated ingredients and governed by repeated laws, then worlds may recur. Histories may recur. Even the delicate structure we call a person may not be protected forever from repetition. Perhaps somewhere beyond every visible star, another Earth exists. Perhaps another version of you exists. Perhaps the exact arrangement of your life could, in principle, happen again. These thoughts are not easy to carry, and perhaps they were never meant to be easy. They press against something very old in us. The desire to be singular. The comfort of believing that what we love, what we lose, what we endure, and what we become exists only once in all of reality. There is tenderness in that belief. There is also fear in it. If a life happens only once, then everything inside it can feel unbearably fragile. Maybe that is why ideas like eternal return have followed human beings for so long. Long before cosmology gave us state spaces and recurrence theorems, people already sensed that existence might not be a simple line. They saw cycles in the natural world. Days returned, seasons returned, tides returned, moons waxed and waned. Birth and death passed through generations. The world itself seemed to move in rhythms, and from those rhythms came a question that has never fully gone away. Does reality return in deeper ways too? Does time bend back? Does life echo? Does what happens once remain once? Philosophy approached that question through meaning. Science approached it through awe. And somewhere between them, the idea became more powerful than either approach alone. That is what makes this subject so unusual. It is not only about cosmology, and not only about existential reflection. It belongs to both. Physics asks whether recurrence is permitted by the architecture of reality. Philosophy asks what such recurrence would mean for a life. The scientist and the solitary insomniac end up standing surprisingly close to each other, even if they arrived there from different roads. Still, after all of this, one important truth remains. Whether or not your life repeats elsewhere, or later, or in some incomprehensibly distant region of a lawful cosmos, this life remains the only one you are directly given from the inside. That may sound obvious, but it is worth saying carefully. Another version of you, if such a being exists, would not relieve this version of you from being alive. A duplicate elsewhere would not absorb your choices. A repeated world would not carry your grief for you. Even in a universe where recurrence is possible, local existence remains local. This breath is still yours to take. This quiet room is still yours to inhabit. This particular sequence of ordinary days still belongs to this stream of awareness. And perhaps that is where the idea becomes unexpectedly gentle. At first, recurrence can feel threatening. It seems to steal uniqueness. It seems to tell us that our lives are only patterns, that our most intimate moments might be repeated elsewhere, that our precious feeling of one-time existence is not secure in the absolute sense we once assumed. But after that first disturbance, another possibility begins to appear. Maybe value was never dependent on absolute singularity in the first place. A sunset is still beautiful even though sunsets happen every evening in different parts of the world. Music is still moving even though melodies can be played again. Love is not made less real because someone else, somewhere else, also loves. Meaning does not necessarily depend on being the only instance of a thing. Sometimes meaning comes from depth, not exclusivity. From being lived, not from being numerically alone. That is an important shift. It means that a life does not need to be the sole occurrence in all of reality to matter completely here. Your pain still matters because it is felt. Your joy still matters because it is lived. The quiet mercy you offer another person still matters because it changes this world, this moment, this thread of cause and effect. Recurrence elsewhere, if it exists at all, does not drain the reality of what is happening here. It only enlarges the frame around it. And perhaps that enlarged frame changes the mood of existence in another way too. It softens loneliness. Not social loneliness, not the loneliness of needing another human being in the room. Something more cosmic than that. The loneliness of imagining that life, mind, memory, and meaning happened exactly once in a universe otherwise filled with indifferent silence. If recurrence is possible, then maybe reality is not so barren. Maybe the universe is not a place where one fragile spark rose and vanished in complete isolation. Maybe it is a place rich enough to echo even its most delicate forms. Worlds, minds, histories, questions. There is a kind of comfort in that, though not a simple one. Not a sentimental comfort. More like the comfort of realizing that the universe may be stranger and more fertile than we first feared. Of course, there are shadows here too. Boltzmann brains reminded us that not all recurrence is equal. Not every repeated observer would carry the continuity and depth that give life its richness. A mind that appears as a statistical accident, complete with false memories and no real world behind it, is not the same as a life genuinely lived through time. That distinction matters. A world matters. History matters. Continuity matters. A self is not just a frozen pattern. It is also a story unfolding in place, in time, in relationship to causes that came before. This may be one of the most valuable lessons of the entire journey. A consciousness is richest not merely because it exists, but because it belongs to a body, to a world, to a language, to a long chain of events that make memory more than appearance. Another Earth means more than another rock. Another you means more than another arrangement of atoms. What matters in these ideas is not only duplication, but continuity. Not only structure, but story. And that, perhaps, brings us back to the human center of all this. When people ask whether life repeats forever, they are often not really asking for a technical cosmological answer. Not only that, at least, they are also asking something quieter. Does anything persist? Does anything return? Is my life sealed inside one narrow corridor of time, or does it belong to something larger? Are my days merely passing, or are they part of a reality more patterned than I can see from here? Science cannot answer every emotional layer of that question. It cannot tell you that your particular life is guaranteed to come back. It cannot promise that every lost moment will be restored, or that every love will recur, or that suffering will somehow be made meaningful by repetition alone. Physics is more careful than that. It speaks in conditions, probabilities, and structures. It tells us that recurrence may be possible if the universe is infinite, if state spaces are finite in the relevant sense, if lawful processes are given enough room or enough time. It opens the door. It does not walk through it for us. But perhaps opening the door is enough. Because once the possibility is seen, we can no longer live quite as casually inside the assumption of absolute one-time-only existence. The ordinary hour becomes a little stranger. The passing day becomes a little more textured. The local world beneath our feet becomes both smaller and deeper. Smaller because it may not be the only one. Deeper because it may participate in a much larger grammar of reality than we realized. There is also a practical wisdom hidden here, almost embarrassingly simple after so much cosmic scale. If a life could repeat, then perhaps it deserves to be lived more consciously. Not dramatically. Not in panic. Not with the strained feeling that every second must become legendary. That is not how real life works, and it would only make a burden out of existence. More gently than that. More humanly. Perhaps the possibility of recurrence is just a reminder not to sleepwalk too much. Not to postpone every meaningful thing to a later version of life that never quite arrives. Not to treat ordinary days as disposable because they seem small. After all, what is a life made of if not ordinary days? Most of living is not climax. It is repetition already. Morning light in a familiar room. The way a voice sounds when tired. The feel of carrying unresolved thoughts through the afternoon. The little rituals that anchor us without our noticing. Meals. Walking. Waiting. Working. Resting. Worrying. Looking up at the night and feeling, for a moment, that your own existence is both intimate and impossible. If your life were ever to return, it would be these things returning too, not only the grand moments you would put in a summary. That may be why eternal return, as a philosophical idea, cuts so deeply. It asks whether you could meet not only the extraordinary parts of your life again, but the texture of it, the repetitive parts, the burdensome parts, the unresolved parts, the small kindnesses, the silent hours, the unfinished work of being yourself. That is a difficult question, but not necessarily a cruel one. It can be heard as accusation, but it can also be heard as invitation. Live in such a way that your days become more inhabitable, more honest, more aligned with what you know, quietly, matters. Not perfect. No life is perfect, but more awake, more present, less postponed. Maybe that is one of the best things this cosmic perspective can offer. Not certainty about recurrence, but seriousness about presence. And there is another kind of calm hidden here too. A release from the pressure of absolute centrality. Human beings often swing between two exaggerated stories about themselves. In one story, we are everything, the center, the purpose, the singular event around which reality bends. In the other story, we are nothing, a meaningless accident in a cold and indifferent universe. But perhaps both stories are too simple. Perhaps the truth is gentler and stranger. We are not the center, and yet we are not nothing. We are lawful expressions of a universe capable of matter, life, mind, memory, and wonder. We are local, fragile, finite, and still profoundly real. A repeated life, if such a thing is possible, would not make us less real. It would simply mean that reality is wider than our first intuition allowed. That a person can matter without being cosmically exclusive. That existence can be precious without being solitary. This way of seeing things also changes the night sky. Once, the stars may have looked like distant scenery, beautiful but unrelated to the inner life. Then science made them physical. Suns, fusion, gravity, chemistry. Then cosmology made them historical, the products of deep time and cosmic evolution. And now, after all these reflections, they begin to look statistical as well. Signs that the universe repeats ingredients, repeats forms, repeats pathways. They are not only lights. They are hints that lawful patterns may extend farther than our imagination likes to go. Somewhere, perhaps, another world carries oceans under moonlight. Somewhere, perhaps, another being asks whether anything like this is possible. Somewhere, perhaps, a life astonishingly similar to yours unfolds in quiet ignorance of your existence. Or perhaps not. Perhaps the universe is finite in the relevant way. Perhaps recurrence never reaches the exact delicacy of a human biography. Perhaps this life is singular after all. Science has not closed the case. But what matters, maybe, is that we have learned to see the question clearly. And in seeing it clearly, something inside us becomes a little less rigid. We no longer need the old false comfort that meaning depends on absolute uniqueness. Nor do we need the opposite false despair that if recurrence exists, nothing matters. Both reactions are too quick. The calmer truth is that meaning survives both singularity and repetition. A lived life matters because it is lived. This world matters because it is inhabited. Your days matter because they are the medium through which consciousness meets reality. There is also a certain humility in accepting that some questions remain open. The universe does not owe us complete transparency. We are small creatures inside a system vast enough to include dark matter, black holes, quantum uncertainty, and cosmic expansion. It would be surprising if such a reality gave up all its answers in forms immediately digestible to the human mind. Some mysteries may remain at the edge of what we can formalize. Some may remain forever partly philosophical even when physics speaks. That is not failure. It is simply the shape of being a finite mind trying to understand a very large thing. And yet our finiteness does not prevent understanding altogether. We have learned something real. We have learned that infinity changes what rarity means. We have learned that repeated ingredients under repeated laws can produce repeated structures. We have learned that consciousness may depend on pattern in ways that make recurrence thinkable. We have learned that some forms of recurrence preserve story while others only mimic it. We have learned that exact life repetition may not be easy to dismiss in principle, even if it remains uncertain in fact. And perhaps most importantly, we have learned that a human life can be placed inside this enormous framework without vanishing into insignificance. That last point deserves to rest for a moment. You do not disappear just because the universe is large. Your life does not become less intimate because cosmology is impersonal. Your choices do not become weightless because somewhere, perhaps, patterns recur. A small life can still be a complete one from the inside. A finite consciousness can still contain immeasurable depth. A fleeting hour can still matter fully, even in a universe where stars live for billions of years and recurrence may operate across scales that dwarf all human history. Vastness does not cancel intimacy. It only surrounds it. And maybe that is the best place to end. Not with an answer so sharp that it pretends all mystery has been resolved, but with a clearer way of holding the mystery itself. Your life may be singular in the strongest possible sense, or it may be one instance of a pattern that reality can express more than once. It may never repeat, or it may already be repeating somewhere beyond every reachable horizon. Physics leaves that question open, though no longer trivial. Philosophy leaves it alive, though no longer innocent. Between them, what remains is a gentle and difficult invitation. Live as though this life is real enough to matter completely, whether or not the universe ever echoes it. Notice the ordinary parts. They are the fabric. Be careful with what you harden into habit. Be honest about what you would not want to relive. Be grateful for what you would. And when the night feels large, as it sometimes does, remember that largeness need not erase you. It may simply mean that your existence belongs to a universe far richer than the frightened part of the mind first assumed. If these quiet journeys through science, space, and the deeper questions of being help you rest, you can leave a gentle like, subscribe, or share a thought below. And if you feel like it, I'd love to know where in the world you're listening from tonight. For now, let the question settle without forcing it shut. Will your life repeat forever? Perhaps. Perhaps not. But either way, you are here now, in one quiet corner of a vast and lawful universe, alive inside a pattern of matter capable of wondering about its own return. That alone is strange. That alone is beautiful. And that alone may be enough to let the mind grow still. So as the stars continue their patient silence, and as this small world turns under them, you can let the thought drift gently into the background. Somewhere between one life and many lives, between singularity and recurrence, between law and meaning, there is this moment. This one. And whether it happens once or echoes forever, it is here now.